The universe has always been a quiet thing, though its quiet stretches beyond the reach of sound. When we think of it, we often imagine explosions, light, and the swirling fire of stars, but beneath that brilliant surface lies something far gentler, something that moves as if the cosmos itself were exhaling after an infinite pause. The universe's slow breath is not made of air or wind, it is time, expanding softly in every direction, stretching the fabric of everything we know. It is the calm rhythm that has guided galaxies since the first spark of existence. In the beginning, this breath was a violent sigh. Space bloomed outward from a point smaller than imagination could hold, and yet, that expansion was not an explosion but an unfolding, like a flower made of space-time petals. Every star, every atom that would ever form, was already coded into that first inhale. And as it spread, the energy began to cool, softening into light, matter, and dust. This slow cooling was the universe's first long exhalation, a serene easing into structure after the chaos of birth. As time passed, that breath carried galaxies outward, adrift like lanterns in an ever-widening ocean. They spun and shimmered, but they also listened to the silence, to the invisible hum of the cosmic microwave background that whispered stories of the beginning. The breath did not stop, it only changed pace. Sometimes it quickened, sometimes it slowed, but it never ceased. In its rhythm, there was an almost meditative quality, a cosmic pulse that held everything in its invisible cradle. Imagine watching a galaxy form, not in moments, but in eons. A faint cloud of hydrogen, swirling, folding, compressing until the first stars ignite. That light, billions of years old, drifts outward in all directions, brushing the edges of time itself. Every flicker of starlight is a note in the great breath, each pulse of energy a heartbeat in the chest of eternity. The universe breathes not in seconds, but in epochs, and in each one, something new stirs from the dark. We often think of space as still, but stillness in the cosmos is an illusion. Even now, everything moves, galaxies drift apart, stars age, planets wobble in their orbits. The universe inhales by creating, and exhales by dispersing. The breath is endless, flowing through the dark corridors of space, through clusters of galaxies that shimmer like frost on black glass. To see it clearly, one must slow the mind until time itself becomes fluid, until expansion feels like a gentle sigh across billions of years. In its inhale, gravity gathers. Clouds of gas fall inward, stars ignite, planets coalesce, and life dares to flicker. Creation is always a drawing inward, a cosmic lung filling with potential. But in its exhale, entropy reigns. Stars burn out, their ashes scatter, and the glow of galaxies dims as matter thins into mist. Yet both sides of this cycle are one motion, the inhale and exhale of existence. Even in decay, there is quiet beauty, for it gives birth to the next inhale. The slow breath carries meaning in its balance. For if it expanded too quickly, no stars would form. If it slowed too soon, the universe would collapse back into itself. Somewhere between the two, there is harmony, a perfect, unhurried rhythm that allows light to live and matter to dance. It is this rhythm that cosmologists trace in the redshift of distant galaxies, in the faint radiation that still hums from the dawn of everything. They are listening for the pattern of that breath, trying to understand how it began and how it might someday end. When we gaze at the night sky, what we see is the breath frozen in its motion. Each point of light is both a spark and a sigh from an age long gone. The stars tell stories not just of what is there, but what once was, carried by the universe's slow exhalation. And even the darkness between them, cold, silent, endless, is part of the rhythm. For every star's birth demands a stretch of emptiness to hold it, every soundless void another part of the lung that lets the cosmos breathe. In that vastness, time is not a straight line but a ripple in the air of existence. It flows differently across the cosmic fabric, bending around gravity, slowing near black holes, racing across voids. To think of the universe's breath is to imagine time itself breathing, swelling and thinning as events unfold. Perhaps, in the farthest corners of reality, there are moments still untouched by the first exhale, waiting patiently to awaken as the wave of expansion reaches them. The galaxies we see today are ancient embers of that first inhalation. Some have already drifted too far to ever be seen again, pulled beyond the cosmic horizon by the accelerating expansion. Their light will fade, their whispers lost in the stillness beyond reach. Yet even their vanishing is part of the same slow breath, the exhale lengthening, thinning, cooling into silence. It is not death, but rest. The cosmos, like all living things, needs its moments of quiet. If we could hear it, the breath would sound like nothing we know, a vibration too deep, too vast to be caught in ears or instruments. But it is there, in the way particles drift, in the slow stretch of space-time. Astronomers can trace it through redshifts, through patterns in radiation left from the Big Bang. The universe speaks softly, but it never stops speaking. Each wave, each photon, each ghost of energy is a word in the endless conversation between expansion and stillness. And just as a breath sustains life, the universe's rhythm sustains reality itself. Without it, there would be no direction, no passage of moments, no change. Motion gives meaning to existence, and rest gives meaning to motion. It is this alternation, this eternal inhale and exhale, that defines the very essence of being. When we look up, we are seeing both the breath and the dream of the universe, forever in balance. At the heart of every galaxy lies a black hole, a counterpoint to creation, a place where gravity becomes silence. These are the lungs' pauses, the moments between breaths. Matter falls inward, crushed beyond recognition, but even that fall feeds the rhythm. The outflows of radiation, the jets of particles that burst from the edges, seed the cosmos with new energy. The inhale may draw matter in, but the exhale spreads it back into the stars. This balance is delicate. Astronomers now believe that the universe's breath is accelerating, pushed by something they call dark energy. It is as if the cosmos is sighing faster, stretching wider, unable to slow itself down. No one knows why this exhale grows stronger, only that it does. Perhaps, one day, the breath will thin so much that galaxies will drift apart forever, and light itself will fade. Or perhaps there will be a reversal, an inhale so long and deep that everything falls back into a single point once more. Yet, there is comfort in knowing we exist in the middle of that breath. Our stars are still young, our galaxies still near. We live in the moment between creation and fading, between the rise and fall of cosmic air. To understand this is to feel a kind of peace, to know that all things, great or small, follow the same rhythm. From the smallest atom to the largest cluster, everything sways to the same hidden pulse. We often think we are separate from the universe, tiny observers standing apart. But we are made of its breath. Every atom in our bodies was born from stars that once burned in the early. Inhale. Every heartbeat is a faint echo of that greater rhythm, every exhale a reflection of the cosmos expanding. The connection is not poetic, it is literal, written in our atoms, in the dust that became flesh. In this way, the universe is not distant, not foreign. It breathes through us, and we breathe with it. When we sigh beneath a starry sky, we are joining that same rhythm, participating in the ancient inhale and exhale that began billions of years ago. The breath moves through all things, through the stones, the oceans, the clouds, and through us. It unites everything in silence, in motion, in the patient unfolding of time. Somewhere, perhaps, there are other beings looking out into the dark, feeling the same quiet awe. They too are part of the breath, their worlds moving through the same expansion, their stars pulsing to the same unseen beat. Across unimaginable distances, every form of life is part of the same exhale, caught in the same cosmic flow. The breath links not just atoms and galaxies, but every thought that ever wondered where it came from. Even in its vastness, the breath is intimate. It touches the smallest grain of dust and the farthest star alike. It knows no borders, no divisions, no end. To sense it is to understand that we are part of something infinite, not lost within it, but belonging completely. The breath does not judge or hurry, it simply is. It continues whether we see it or not, whether we understand it or forget. Perhaps, when all lights fade and all energy settles, the universe will finally rest. The breath will pause for the briefest eternity, waiting before it begins again. From that stillness, another inhale will rise, another unfolding, another birth. Time will stretch anew, stars will form again, and the rhythm will start over, soft, slow, endless. Until then, we drift within it, small but awake, fragile but aware. We ride the current of expansion, carried by the universe's slow breath through the sea of time. And somewhere in that motion, in that gentle exhale of infinity, lies the quiet truth that everything that ever was, and ever will be, is still breathing together. It began not with light, but with a silence so complete that even time did not yet know how to move. Before the first stars blinked awake, before matter had taken shape, there was only a dense, unseen pulse of potential. The universe was still holding its first breath, trembling at the edge of creation. And from that trembling came the mystery, the moment when nothing became something. It is a question that still hums through physics and philosophy alike. What stirred the void into existence, and why did it choose to awaken? In that instant, the universe unfolded faster than thought. A bloom of energy spread from a single, unknowable point, carrying the seeds of all things: space, time, light, and the laws that would govern them. Yet even as it expanded, no one knows what triggered it. Was it a fluctuation in a field? A spark from a prior cosmos? Or was it simply the inevitable awakening of potential, the way still water eventually ripples under its own weight? The birth of this mystery is not just an origin story, it is the reason curiosity exists at all. Scientists call it the Big Bang, but the name hides its subtlety. It was not an explosion that sent matter flying into empty space, but rather an expansion of space itself, like a breath that carried everything with it. Space and time stretched together, forming the first framework of existence. But what came before it remains hidden, unreachable by light or logic. The boundary between nothing and something lies beyond understanding, wrapped in silence that science can only trace with equations. In the earliest fraction of a second, the universe grew from smaller than an atom to larger than galaxies. It was smooth, glowing, and hot beyond imagination. Yet within that perfect fire, tiny imperfections stirred minute ripples in density that would one day become galaxies, stars, and life. Those flaws, those subtle asymmetries, were the beginning of everything complex, the fingerprints of imperfection that gave rise to beauty. Without them, the universe would have stayed a uniform blur of light, forever still and empty. As the universe cooled, it began to reveal structure. Particles collided, merged, and fell apart in an elegant chaos. Quarks joined into protons and neutrons, photons scattered wildly, unable to travel far. For nearly 400,000 years, light was trapped in that dense plasma, a glowing fog where matter and radiation danced in a furious waltz. Yet even in that blinding brightness, the mystery deepened. Why did matter survive over antimatter? Why was there something left to glow at all? When the universe finally cooled enough, atoms formed, and light escaped at last. This light still moves through the cosmos today, faint but eternal, known as the cosmic microwave background. It is a whisper from the dawn, carrying the memory of the first breath of creation. Every telescope that listens to it is hearing the heartbeat of that mystery, the faint echo of a beginning that has never truly ended. For even now, the expansion continues, faster, quieter, more elusive. Yet, as clarity came, so did confusion. The more precisely we measure the early universe, the stranger it becomes. Its balance is too perfect, its structure too uniform, its expansion too smooth to have come from randomness alone. Something unseen shaped it, something neither matter nor light. Dark matter, dark energy, invisible hands guiding the expansion like soft gravity's ghosts. The universe was not just born, it was sculpted by forces we cannot yet name. We know these forces exist only through their effects. Galaxies spin faster than their visible mass allows, light bends around invisible halos, space itself stretches as if pushed by a silent pressure. Dark matter binds the universe together, while dark energy tears it apart. They are opposites, yet they coexist, two unseen architects whispering from the beginning. Their origin may lie in that same first moment, born alongside light but hidden within its brilliance. For humanity, the birth of the universe is not only a scientific event, it is a spiritual one. It asks questions we cannot avoid. If everything emerged from nothing, what does that mean for us, the observers? Are we fragments of that first mystery, thinking reflections of its earliest light? The human mind, curious by design, cannot resist tracing itself back to that first breath. Somewhere within us, perhaps, lies the echo of the universe wondering about its own creation. Each discovery deepens the mystery rather than solving it. Inflation theory explains the smoothness of the cosmos, but it raises new questions. What caused inflation? What stopped it? And if space can expand endlessly, might other universes have formed beside ours, invisible bubbles in a cosmic sea? The birth of one universe may not have been a singular event, but one note in a grander symphony of realities. Ours may simply be the one tuned for awareness. Even now, scientists look back through telescopes like archaeologists of light, peeling back time itself. Each photon captured from deep space is a message from the past, a memory from when the universe was young. The deeper we look, the younger it becomes, until we reach that faint glow of the microwave background, the limit of sight. Beyond that lies darkness, not because there is nothing, but because light has not yet had time to reach us. The beginning is still traveling. The beauty of the birth of this mystery lies not in its answers but in its endurance. Every culture, every civilization has asked the same question: what was before? The myths of creation, the songs of gods and worlds, are all attempts to paint the same blank canvas. Science may use equations instead of poetry, but both reach for the same truth, that something extraordinary began in silence and still continues in motion. The mystery is not outside us, it is the very reason we exist to question it. Even the smallest particle holds traces of that birth. The hydrogen in the sun's heart, the carbon in our blood, all were forged from the ashes of stars that themselves were born from the first atoms. In every breath we take, in every spark of thought, the universe's origin lives on. We are walking remnants of the first second, thinking dust shaped by time. The mystery's birth was not a distant event, it is alive within us, carried forward in motion and memory. Sometimes, when we imagine that first moment, it feels too abstract, too immense to belong to reality. But imagine it this way: a single breath, invisible and soundless, filling an endless darkness. From that breath, warmth spreads, light blossoms, and the seeds of galaxies drift outward. It is not an explosion, but a slow blooming, a flower of creation opening into the void. That is how the universe was born, softly, inevitably, beautifully. There is another mystery intertwined with the birth of the cosmos, time itself. Before that first expansion, there was no before. The clock began only when space began, meaning that the question what came before has no meaning in that context. Time is a property of the universe, not its parent. The birth of a mystery is, in part, the birth of time's first heartbeat, a rhythm that everything since has followed. From the first second onward, the universe began writing its story. Hydrogen turned to helium, stars ignited, galaxies spun like golden spirals in the dark. Each event, every collision, every glow, was an unfolding chapter. But the mystery is not just about how it happened, it is about why such order came from chaos. Physics can describe the motion, but not the intention. Perhaps, in that gap, lies the true wonder of existence. As expansion continued, gravity began its gentle work, pulling, gathering, shaping. Within the silence, clouds formed and collapsed, light returned again and again in new forms. The simplicity of hydrogen became the complexity of stars, and through those stars, the elements of life emerged. The universe was already writing toward consciousness, even if it did not yet know it. That, too, is part of the mystery, that chaos could dream of order, and order could someday dream of itself. Some theories suggest the universe may have no true beginning, that it cycles through births and collapses endlessly. Each collapse gives rise to another expansion, another breath. If true, then our universe is not the first, nor the last, but one in an infinite rhythm of awakenings. In that sense, the mystery's birth is not a single event, it is a pulse that beats eternally through reality. When we speak of nothing, we imagine emptiness, but perhaps the void was never truly empty. Maybe it was pregnant with potential, fields vibrating at the edge of awareness, waiting for the moment to unfold. The universe, then, was not created out of nothing, but out of a deeper kind of fullness, a hidden energy that needed only the smallest disturbance to become everything. The mystery, therefore, is not how something came from nothing, but how nothing ever seemed so still. Even today, that first breath continues. Space expands, galaxies drift farther apart, and time stretches thinner. The birth of the mystery was not a moment locked in history, it is an ongoing act. We live inside its unfolding, participants in its endless creation. Every thought we have, every discovery we make, is part of the same long awakening that began billions of years ago. And perhaps, when all is said and done, the mystery will not be solved but understood in a different way, not through equations, but through experience. When the stars fade and the universe grows quiet again, the breath may pause, only to rise once more. The cycle may continue, each time more refined, more aware. The birth of the mystery is not a story that ends, it is one that continues, quietly, in every heartbeat of the cosmos. In the end, the universe's birth is not only the origin of matter, but the birth of wonder itself. The questions we ask, the awe we feel, the longing to understand, all are fragments of that first spark, the mind of the cosmos awakening to itself. We are the mystery's echo, thinking, feeling, and dreaming within the light it left behind. And as we gaze into the stars, we are not merely looking backward in time, we are looking inward, toward the same miracle that began it all. The universe, for all its brilliance, is mostly made of things we cannot see. Behind every glowing star and every drifting cloud of gas lies a deeper substance, dark, quiet, invisible. When we look into the cosmos, we are staring into a veil woven of shadows, light flickering through thin cracks of what is truly there. The stars we see are only the embroidery on a vast, unseen fabric. Most of reality hides behind the curtain of what physicists call dark matter and dark energy, names that sound poetic but signify our ignorance. Even the brightest galaxy is surrounded by a halo of invisibility. Dark matter does not shine or absorb light, yet its gravity holds galaxies together, like invisible hands cupping the delicate spirals of stars. Without it, galaxies would tear themselves apart, their stars flung into the void. We know it exists not by its presence, but by its influence, the quiet tug that bends starlight, the speed at which stars orbit their centers, the subtle shape of cosmic webs stretched across the universe. The shadows reveal themselves through their grip. When we map the large-scale structure of the cosmos, we find something hauntingly beautiful, a vast network of filaments made not of stars, but of dark matter. Between these filaments lie immense voids, empty expanses where galaxies are rare. The visible universe traces only the outline of this dark skeleton, like frost tracing the edges of a windowpane. We are made of the faintest part of existence, the luminous dust floating between the unseen bones of creation. Light may show us where we are, but darkness tells us how we got there. For centuries, humans believed that what they saw was all that existed. The stars, the planets, the faint haze of distant galaxies, these seemed complete. Yet when astronomers began to measure the cosmos more carefully, they discovered an imbalance. The universe's visible matter could not account for the motions they observed. Something invisible was anchoring everything in place. It was a humbling revelation that the majority of existence does not care to reveal itself to our eyes. Dark matter makes up about 27% of the universe's total content, while everything we can see, stars, planets, people, adds up to less than 5%. The rest, an even greater enigma, is dark energy, a force that pushes space itself to expand faster and faster. These two unseen presences define everything. One binds, the other repels. Together, they form a cosmic duet, a push and pull that shapes the very destiny of the stars. The universe is not just filled with light, it is sculpted by shadows. To understand the shadows, scientists build machines that stare into nothingness. They bury detectors deep underground, hoping to catch a rare collision with a dark matter particle. They send satellites into orbit to measure the faint distortions of cosmic light, searching for signs of invisible mass bending space. Each experiment is an act of faith, a whisper into the void. So far, the shadows have not answered directly. They remain silent, patient, indifferent to our searching. But we know they are there. The evidence is written into the star's motion, undeniable as gravity itself. Dark energy is even more elusive. Unlike dark matter, it does not gather or cling, it pushes. It acts as a pressure woven into the fabric of space-time, causing galaxies to drift apart faster than before. The discovery of this acceleration, in the late 20th century, changed our view of the cosmos forever. Instead of slowing down, as gravity should have ensured, the expansion was speeding up. The universe was not coasting into old age, it was running, stretching, escaping itself. And no one knows why. Some think of dark energy as the breath of the cosmos, an invisible wind pushing everything outward. Others see it as a property of space itself, a built-in restlessness that grows as the universe grows. Whatever it is, it dominates everything, making up nearly 70% of existence. That means the world we know, the galaxies we see, the atoms that make up our lives all belong to a tiny island of matter adrift in an ocean of shadow. We are the exception, not the rule. The phrase dark universe sounds ominous, but in truth, it is serene. Darkness in space is not malevolent, it is simply unknown. It hums quietly beneath the surface of existence, invisible but present. It is the scaffolding that holds stars in their places, the hidden current that carries time forward. Without it, the universe would be chaos, its light too fragile to survive. The shadows are not absence, they are structure, the bones of being. What makes the mystery even deeper is that dark matter and dark energy do not seem to interact with light or with us. They pass through matter as though we aren't there, ghostly and detached. We might be surrounded by them this very moment, swimming unknowingly in a sea of unseen particles that slip between our atoms without a trace. It's a humbling reminder. That perception is not truth, that what we can see is only a thin layer of a much larger reality. Some scientists imagine that dark matter may be composed of undiscovered particles, WIMPs, actions, or other exotic forms of matter that whisper between the folds of physics. Others suspect it might not be matter at all, but a sign that our understanding of gravity is incomplete. Every theory opens new questions, and every answer slips away like shadow under sunlight. The more we learn, the larger the dark grows, stretching endlessly into the unknown. In this darkness lies both terror and beauty. The idea that most of reality is invisible can make us feel small, even fragile. Yet it also expands our wonder. The cosmos is more mysterious than we ever dared to dream. It means there are still stories untold, realms uncharted, and truths waiting in the quiet. The shadows are not a wall, they are an invitation, a whisper from the universe saying, "Look deeper." Dark matter weaves galaxies into webs, while dark energy pulls them apart. This delicate balance determines the fate of everything. If dark energy wins, galaxies will drift away until the sky goes black, stars isolated in infinite emptiness. If dark matter someday dominates again, gravity may pull everything back together, collapsing the universe into a single point once more. Between these two invisible forces, the cosmos breathes a long, slow inhale and exhale that defines eternity. Our own galaxy floats on the edge of these forces. The Milky Way spins in quiet balance, its luminous spiral arms bound by the gravity of unseen mass. Beyond it, other galaxies shimmer like distant embers in a dark sea. Each is held in place by a halo of shadow, unseen but essential. It is a silent harmony, a dance choreographed by something that has no light but endless influence. We exist because the dark allows light to form. It is strange to think that we understand the surface of stars better than the depths of this darkness. We can describe nuclear fusion and the death of suns, but not the nature of what holds those suns in place. Perhaps it is because the universe keeps some secrets to itself, preserving mystery as a kind of balance. To reveal everything at once would break the spell, end the story too soon. The shadows keep wonder alive. When we look out with telescopes, we are really peering through layers of the unknown. Every photon we detect has traveled through fields of dark matter, bent subtly by gravity we cannot see. Each distant glimmer has been shaped by something unseen, arriving in our eyes as evidence of what hides behind it. In this way, even darkness leaves fingerprints on light, as though the universe cannot help but reveal its secrets in small, delicate ways. Some philosophers wonder if dark matter and dark energy are not separate things, but two faces of one deeper principle, an unseen order that keeps balance. Perhaps they are not substances at all, but expressions of geometry, the way space curves and breathes. If so, then the universe is a living fabric, its shadows merely the folds of its body. To study darkness would then be to study the self-awareness of reality. There is poetry in the fact that we call it dark. In truth, the word describes not what it is, but what it withholds. The shadows are not black, they are simply beyond sight. Just as a deep ocean looks dark from the shore, though light dances beneath its surface, the cosmos hides depths we have not yet learned to see. One day, our instruments may pierce that veil. Until then, we must listen to the echoes, the subtle tugs and glows that hint at the shape of the unseen. In ancient myths, darkness was always the beginning, the womb of creation, the place from which gods and worlds emerged. Science, in its quiet way, has returned to that truth. The universe was born from darkness and still carries its memory. Every atom of light was born in shadow, and every photon carries the imprint of the unseen. To explore the dark universe is to return to our origins, to peer into the cradle of existence itself. Yet the more we learn about these shadows, the more we realize how little we know. The equations describing dark energy fit the data, but they offer no explanation for why it exists. The same is true for dark matter. It works perfectly in our models, yet resists every attempt to reveal itself. The universe seems content to let us see its outline, but not its face. Perhaps the mystery is part of its nature, not a flaw in our understanding but an invitation to keep wondering. Every night, when we gaze at the stars, we are surrounded by that invisible ocean. It presses against us from every direction, silent and infinite. The air around us, the ground beneath us, the spaces between atoms, all soaked in the same unseen presence. It is not just out there, it is here, intimate and immediate. We live in a world of light, but we are shaped by shadow. And so, the universe is filled with ghosts, not the kind that haunt, but the kind that hold. They cradle galaxies, carry time forward, and keep everything from unraveling. They are patient, eternal, indifferent to our fears. We may never see them directly, but their fingerprints are everywhere, written in the quiet architecture of the cosmos. Light gives us vision, but shadow gives us meaning. Perhaps, one day, we will finally lift the veil and see what the universe has been hiding. But until then, we drift within it, tiny sparks flickering in a sea of darkness, held by invisible hands, guided by forces older than stars. We may call it dark, but in truth, it is the gentlest mystery of all, the quiet presence that lets light exist, the hidden pulse that keeps the universe alive. When the universe began to grow, its movement followed patterns not of chaos, but of structure, rules embedded within the very nature of space-time. These rules, later written down as equations, describe how distances stretch, how light travels, and how matter thins as the fabric of space expands. The universe has never needed words to express these laws. It speaks through ratios, constants, and geometry. The equations of expansion are silent, yet they govern the largest scales of existence with unbroken precision. At the center of this understanding stands Einstein's field equations of general relativity. They describe how matter and energy shape the curvature of spacetime, and how that curvature dictates motion. From them arises the principle that space is not passive, it bends, flexes, and expands according to what fills it. When applied to the universe as a whole, these equations reveal that everything within space is carried along as the space itself grows. It is not objects moving through the void itself stretches. In the early 20th century, Alexander Friedmann and Georges Lemaitre took Einstein's equations and applied them to a dynamic cosmos. Their solutions predicted that the universe should not be static, it must either expand or contract. At the time, this was an unexpected result. The prevailing view held that the cosmos was fixed and eternal. Yet the mathematics did not agree. The silent logic of the equations pointed toward motion, toward a universe that breathes rather than stands still. Observational evidence came later through Edwin Hubble, who found that distant galaxies were receding from us, their light stretched toward the red end of the spectrum. The farther away a galaxy was, the faster it appeared to move. This was not due to any explosion, but the direct effect of spacetime expanding. Hubble's law became a cornerstone, linking mathematics to observation. The universe's expansion was not theory alone, it was measurable. The Friedmann equations simplify Einstein's complex tensors into something more specific: relationships between the expansion rate, density, and curvature of the universe. They show that how fast space grows depends on how much matter and energy it contains. Too much matter, and the expansion slows; too little, and it accelerates. Embedded within them is the Hubble parameter, a measure of how quickly the universe stretches at any given time. The cosmos follows these equations with quiet consistency. As the universe aged, the balance between matter and energy shifted. Early on, radiation dominated, dictating the tempo of expansion. Later, as matter formed and clustered, its gravity began to slow the outward motion. Now, as dark energy takes precedence, the expansion accelerates once more. The equations remain the same, only the dominant term changes. They are indifferent to time's flow, yet they describe it with precision, showing how one era gives way to another through simple mathematical transitions. Every constant in these equations carries meaning. The gravitational constant links geometry to force, while the cosmological constant represents an inherent pressure within space. Einstein originally introduced the cosmological constant to maintain a static universe, then discarded it after Hubble's discovery. Decades later, it returned, this time as a description of dark energy's accelerating influence. The constant's quiet persistence in theory reflects the consistency of mathematics even when human understanding shifts. The expansion itself is uniform on large scales. Local systems like galaxies remain bound, but beyond them, space stretches evenly in every direction. The equations predict this homogeneity, explaining why the universe looks similar wherever we observe. No single point is the center, all regions expand relative to one another. The silent equations encode this symmetry, ensuring that no observer occupies a privileged position. Every vantage point experiences the same cosmic drift. Temperature and density also evolve according to these laws. As space expands, wavelengths of light stretch, cooling the universe. What was once a hot, dense plasma became a transparent sky, and eventually, a vast, dark sea. The equations quantify this cooling precisely, mapping the transition from radiation-dominated to matter-dominated eras. Even the faint microwave background that fills space today follows directly from their predictions, matching observation with remarkable accuracy. The expansion rate is often expressed through the Hubble constant, but determining its exact value has proven difficult. Measurements from distant supernovae and those from the early universe differ slightly, creating what is known as the Hubble tension. Though the difference is small, it challenges our assumptions about the model's completeness. The equations remain solid, but their inputs, how we interpret and measure the cosmos, still evolve. The mathematics hold steady while observation refines its parameters. Underlying these relationships is the concept of critical density, the exact amount of matter and energy needed for the universe to be spatially flat. If the total density is higher, the universe would eventually collapse. If lower, it would expand forever at an ever-increasing rate. Observations suggest we live in a nearly flat cosmos, balanced between these extremes. This balance, described cleanly in the equations, gives structure to everything that follows, the quiet arithmetic of existence itself. In recent years, models have grown more precise, incorporating quantum fluctuations and inflationary phases into the early expansion. Inflation theory proposes that a brief, immense burst of expansion occurred fractions of a second after the beginning, smoothing out irregularities and setting the stage for everything we see. The mathematics of inflation emerges naturally from modifications to the same equations, showing their adaptability to new conditions while remaining rooted in fundamental geometry. On the largest scales, these equations form what cosmologists call the CDM model, lambda cold dark matter. Lambda represents the cosmological constant, cold dark matter accounts for unseen mass. Together they describe a universe dominated by invisible components, with ordinary matter playing a minor but essential role. The model fits nearly all current data, from background radiation to galaxy distribution. Its strength lies not in complexity, but in quiet consistency across multiple lines of evidence. Despite their simplicity, these equations contain deep implications. They show that the universe has no external boundary, no edge to reach. Expansion occurs everywhere, not from a single center. Distances between clusters of galaxies grow, but within galaxies, gravity resists. The result is a layered reality, bound systems within an expanding framework. The mathematics unifies these scales without contradiction, describing both local stability and global motion through a single coherent system. Time itself is intertwined with expansion. The equations show that as the universe stretches, its age unfolds predictably. Each epoch has its own rhythm, dictated by the dominant energy component. Radiation gave way to matter, matter to dark energy, and perhaps one day, dark energy to something new. The same formulas describe them all, silently tracking the shifting balance between gravity and pressure, density and distance. Time is not separate from these variables, it is their outcome. In their essence, the equations are geometric statements. They do not require intention or design, they simply express the relationships inherent to curved space. Expansion arises as a natural solution, just as a circle's circumference arises from its radius. In that sense, the growth of the universe is not a process imposed from outside, it is a property of its geometry. The silence of these equations lies in their inevitability. They do not command, they describe. Even the future of the universe can be extrapolated from them. Depending on the density and pressure of dark energy, the expansion could continue indefinitely or approach a steady limit. In some scenarios, galaxies will recede beyond sight, leaving only cold remnants adrift in isolation. In others, the acceleration may increase without bound, tearing apart structures down to atoms. The equations allow for all outcomes, but observation will determine which the cosmos has chosen. When cosmologists model these outcomes, they run simulations built upon these same mathematical foundations. Virtual universes evolve within computers, matching the real one to remarkable detail. Galaxies form along filaments, voids grow larger, and expansion accelerates precisely as predicted. Each model is a quiet confirmation of the geometry encoded in the equations, demonstrating that the universe behaves as mathematics dictates, without deviation or noise. The connection between theory and observation remains one of modern science's most stable achievements. Each new telescope refines parameters but leaves the core structure untouched. The expansion rate may vary slightly depending on method, but the existence of expansion itself is unquestioned. The silent equations have endured for over a century because they continue to align with what the cosmos reveals, their quiet logic mirroring the consistency of nature. Some thinkers wonder whether these equations will eventually be replaced by a deeper framework that unites general relativity with quantum mechanics. On very small scales, space-time may behave differently than the smooth continuum described by Einstein. Yet even then, the larger pattern of expansion will likely remain a natural outcome of whatever deeper law exists. The equations may be approximations, but they describe truth within the scales we can measure. The silence of these mathematical forms contrasts sharply with their consequence. They govern the stretching of billions of galaxies, the cooling of radiation, and the future of all space. Yet they do so without noise, without interference, only through balance and proportion. The universe expands not because it chooses to, but because the geometry allows no alternative. Motion arises from the structure itself. The simplicity of this principle gives the cosmos its coherence. When written on paper, the equations appear compact symbols, exponents, and constants arranged neatly. Yet within them lies the entire temporal history of existence. Each term represents a different aspect of the universe: density, curvature, energy, and time. Together they form a sentence the universe has been repeating since its first moment. It is not poetic, it is structural. The silence comes from the fact that the equations require nothing beyond themselves to hold true. As the cosmos continues to expand, these same equations will remain valid, even as their variables evolve. The rate may change, the density may fall, and new forces may emerge, but the underlying relationships persist. They are as close to permanence as anything can be within a changing universe. They define the framework within which all events occur, quiet and unobserved, shaping everything that follows. In the end, the expansion of the universe is both a physical and mathematical event. It is not guided by will or purpose, only by the consistency of its own laws. The silent equations describe this process with precision, mapping the growth of space from the smallest scales to the edge of observation. They remain constant in their restraint, unchanging statements of how reality organizes itself through time, expressing the still order that underlies motion. The universe, 4. All its vast smoothness and balance, carries faint irregularities, tiny imprints left behind by its earliest moments. Though the cosmic fabric seems seamless when viewed from afar, closer examination reveals minute fluctuations, slight asymmetries in temperature and density that ripple across space-time. These are not flaws but the fingerprints of creation, traces of quantum noise stretched to cosmic scale by expansion. They are the cracks in perfection, the delicate variations that allowed galaxies, stars, and life to emerge. In the beginning, when the universe was smaller than a grain of sand, it was filled with quantum uncertainty. Energy flickered unpredictably, and regions differed by imperceptible amounts. Inflation, an instant of rapid expansion, magnified these quantum tremors into vast structures, freezing randomness into the geometry of the cosmos. What once was subatomic became galactic. These tiny irregularities seeded everything that would later become matter, motion, and form. The cosmic microwave background, a faint afterglow from the universe's first light, preserves these imperfections like ancient etchings on the sky. When scientists map its temperature, they find tiny variations, differences of only millionths of a degree. Yet those minute spots mark the earliest fractures in the uniform field of energy. The cracks are not destructive, they are creative, revealing the beginnings of structure itself. Without them, the universe would have remained a smooth, silent soup of particles. Gravity amplified these primordial wrinkles over time. Denser regions pulled more matter toward them, growing into stars and galaxies, while emptier regions expanded into cosmic voids. The universe's large-scale structure, its filaments, clusters, and superclusters arose from these initial imperfections. The cracks grew, not through collapse but through balance, where attraction and expansion wove matter into cosmic webbing that stretches across billions of light-years. These patterns suggest that the universe was never meant to be perfectly uniform. Perfection would have left it barren. The delicate irregularities created the possibility of complexity. Each cluster of galaxies, each swirling nebula, each planet owes its existence to an ancient imbalance. In this way, the cracks in the cosmic fabric are less like damage and more like veins of possibility, channels through which the universe learned to differentiate itself. Still, the term crack holds weight, for even at vast scales, the universe shows tension. Space stretches faster and faster, and the filaments of matter appear to thin over time. Dark energy pushes outward while gravity pulls inward, and though the balance holds for now, it reveals a subtle fragility. The expansion's acceleration hints that the fabric itself carries an intrinsic strain, one that could reshape the destiny of all things if it grows unchecked. Cosmologists seek these imperfections not to repair them, but to understand their nature. In studying the cosmic microwave background, they've found alignments and anomalies, the cold spot, for example, a vast region cooler than surrounding space. Some believe it's a statistical fluke, while others suspect it may mark an interaction with a void or a relic from before inflation. Whatever its cause, such features remind us that the cosmos, though governed by order, still carries whispers of something wilder beneath its equations. The cracks also appear in our models. The universe's accelerated expansion defied early predictions, forcing scientists to reintroduce Einstein's cosmological constant under a new name, dark energy. Likewise, galaxies spin faster than visible matter allows, implying vast amounts of unseen mass, dark matter, shaping their motions. These discoveries show that even our understanding of the cosmic fabric has fissures. The more deeply we study the universe, the more we uncover what we do not yet comprehend. Dark matter itself forms an invisible scaffolding, holding galaxies together. It neither emits nor absorbs light, yet it outweighs ordinary matter 5-1. Without it, stars would drift apart, unable to remain bound within galaxies. This unseen structure threads through the universe like a ghostly lattice, connecting clusters in an immense network. It is another kind of crack, an unseen presence that forces us to admit the incompleteness of our vision. Dark energy, even more mysterious, acts as a pressure pushing space apart. It is smooth, omnipresent, and unmeasurable except through its effects. Unlike dark matter, it cannot clump or cluster. It seeps evenly through the cosmos, accelerating expansion in all directions. Its nature is unknown, It could be a property of space itself, a new field, or something beyond current physics. Yet it dominates the universe's energy budget, shaping the fate of everything. The greatest crack, it seems, lies not in the universe but in our understanding. Even the geometry of space contains its quiet fractures. On vast scales, the universe appears flat, but tiny curvatures may exist too subtle for current instruments to detect. These could arise from quantum effects, relics of inflation, or distortions from massive structures. The geometry is not perfectly smooth, it ripples and bends like a stretched fabric under weight. The cracks, then, are not linear breaks but curvatures, bends where gravity leaves its faint signature on space-time. At the edge of observation, where light has traveled for nearly 14 billion years, the cosmic horizon marks another kind of fracture. Beyond it lies a region forever hidden from view, expanding faster than light can reach us. The visible universe is a small patch of an unfathomably larger whole. This horizon acts like a boundary of knowledge, a limit drawn not by distance but by time. Beyond it, the cosmic fabric continues, unseen but not absent. Some physicists believe these cracks could one day reveal clues to parallel universes. If inflation created not one bubble of spacetime but many, our cosmos might be just one among countless others, each with its own physical laws. In that case, the irregularities we see could be the faint signatures of collisions between universes in that ancient inflationary sea. Such a notion stretches the imagination, turning the cosmic fabric into a quilt of infinite possibilities, stitched with unseen threads. At smaller scales, cracks may appear as quantum fluctuations in spacetime itself. Some theories of quantum gravity suggest that space and time are not continuous but granular, made of discrete units. If true, the smoothness we perceive is an illusion born of scale. The tiniest cracks would then be woven into the fundamental texture of existence, invisible yet essential, like the atoms of geometry themselves. The cosmic web, mapped by telescopes and simulations, reveals a universe that looks like a living organism, filaments like nerves, clusters like nodes. The voids between them are vast, dark, and nearly empty. These voids represent absence, the silent spaces where the universe stretches most freely. They are the counterpart to the cracks, places where the cosmic fabric thins almost to transparency. Yet even in emptiness, there is energy, vibration, and subtle motion. Nothing is truly hollow. Galaxies, though bright and dense, are only islands floating on a deep sea of dark matter and expanding space. Their arrangement mirrors the initial irregularities of the early universe. Every star owes its birthplace to those ancient asymmetries. The cracks that began as quantum fluctuations now sparkle as constellations across the night sky, a reminder that beauty arises not from uniformity, but from variance and imbalance. The discovery of gravitational waves added another kind of ripple to this cosmic fabric. When massive objects like black holes collide, they send out distortions that stretch and squeeze spacetime itself. These waves travel silently across the cosmos, carrying information about cataclysmic events billions of years old. They are the vibrations of the universe's structure, the deep music of its fractures, audible not to ears but to instruments tuned to spacetime's subtle pulse. Over cosmic timescales, these fractures may widen. As dark energy drives acceleration, galaxies drift farther apart. The night sky will grow emptier, stars will fade, and eventually, even the faint glow of other galaxies may vanish from view. The universe's expansion will outpace the light that connects its parts, leaving isolated pockets of matter adrift in silence. In that distant era, the cosmic fabric will stretch beyond recognition, its cracks transformed into chasms. Yet within these chasms, the same laws endure. Gravity still binds local systems, time still flows, and light still moves at the same speed. Even as space thins, its structure remains coherent. The cracks, though deep, do not destroy the whole. They redefine it, shaping the evolution of a cosmos that can bend without breaking. The universe's resilience lies in its flexibility, a strength born of imperfection. Scientists continue to search for signs of deeper fractures, departures from known physics that might reveal new layers of truth. They look for hints in cosmic background polarization, in neutrino behavior, and in the slow drift of fundamental constants. Each potential anomaly is a doorway, each deviation a clue. The cracks in our understanding are often the places where discovery begins. In this sense, the cracks are sacred. They represent the places where knowledge gives way to mystery. The cosmic fabric is not torn in despair but opened in invitation, revealing new dimensions of reality waiting to be understood. Like light through a prism, these imperfections refract truth into colors we could not see before. The universe's incompleteness is not a flaw, it is the reason there is still something to learn. Perhaps one day, with deeper observation and refined theory, humanity will trace the cracks to their origin. We may find that they are not fractures at all, but signatures of deeper unity, patterns that connect the smallest quantum fluctuations with the largest cosmic structures. What we call irregularity might, in a broader context, be symmetry misunderstood. The universe could be more complete than it appears, its cracks mere shadows of a higher order. For now, we gaze at the sky and see both harmony and tension. The galaxies flow along invisible threads, the voids open like silent abysses, and the background radiation hums with the residue of ancient expansion. Every bit of it speaks to a balance between creation and decay, between wholeness and fracture. The cosmic fabric holds, but it does not hide its imperfections, it displays them as proof of its living nature. The cracks in the cosmic fabric are, ultimately, the story of the universe's becoming. They remind us that creation requires contrast, that perfection without variation is sterile. Through these small disruptions, matter found structure, and structure found meaning. The universe's silent fractures gave birth to motion, time, and thought. They are not wounds in the cosmos, they are its breath, its pulse, its way of ensuring that nothing remains still forever. And so, when we look upward into the dark, we are not seeing a flaw but a pattern still unfolding. Each faint irregularity, each cosmic anomaly, is part of a grand design that has no final state. The universe continues to stretch, to ripple, to grow. Its fabric may carry cracks, but those cracks are where the light enters, where new understanding begins, and where the story of existence continues to write itself, endlessly, across the widening dark. There comes a moment in every great exploration when discovery no longer lies in finding something new, but in seeing the familiar with new eyes. The universe, once thought to be an infinite expanse ruled by chaos or divinity, has gradually revealed itself as something both vast and intimate. The gentle shift in perspective begins when we realize that the cosmos is not something separate from us, it is the context of our existence, the field from which we arise, and the mirror in which we glimpse our own origins. At first, early astronomers imagined a universe centered around humanity. The heavens were thought to revolve around the Earth, with stars fixed in a crystalline dome. It was a comforting vision, a cosmos built for observation, with clear boundaries and purpose. Yet as telescopes grew sharper and theories deepened, that certainty dissolved. The Earth became one world among many, the Sun one star among billions, and the Milky Way one galaxy adrift in a cosmic sea. With each revelation came a widening of scale, a soft but irreversible expansion of awareness. This shift was not merely scientific, it was philosophical. It asked humanity to relinquish its central position and accept that significance need not depend on size or placement. We learned that meaning could emerge from perspective rather than dominance. The vastness of space did not make us small, it invited humility, a deeper recognition of how intricately we belong to a larger pattern. The more distant the stars became, the more connected we seemed to everything that shines within them. As cosmology matured, another transformation followed. The universe ceased to be seen as static, eternal, and unchanging. Instead, it became a dynamic, evolving entity, one that grows, cools, and transforms through time. This realization reframed everything. The cosmos was not an infinite stage but a story still unfolding, and we were living within one of its chapters. Even the laws of physics became storytellers, whispering the same tale of creation, transformation, and entropy in every direction we looked. When Hubble revealed that galaxies were receding, humanity experienced an existential vertigo. The universe was not a still lake reflecting eternity, it was a river in motion, carrying everything forward. Yet with that disquiet came a strange serenity, the knowledge that expansion itself is natural, and that the stars drifting away are not leaving us but following the same universal current. Perspective shifted from possession to participation. We were no longer observers of the cosmos, we were part of its flow. Every new measurement, every deeper telescope image, refined this awareness. What had once seemed cold and distant began to appear as something alive with structure. Galaxies clustered in filaments like neurons, cosmic webs forming patterns reminiscent of the mind. The parallel was poetic but instructive. Perhaps intelligence, connection, and emergence are woven into the very fabric of matter. Perhaps consciousness, too, is one of the universe's quiet ways of knowing itself. That thought led to a subtler transformation, a recognition that observation itself shapes understanding. We cannot look at the cosmos without interpreting it through our limited senses and instruments. The act of measurement, as quantum physics suggests, affects what is measured. Even in the vast calm of the universe, uncertainty hums at the foundation. This awareness shifted science from the illusion of perfect objectivity to a more reflective stance. We are both the observers and the observed. In this gentle shift, humility replaces certainty. The universe does not owe us explanations, yet it reveals itself in patterns of astonishing coherence. From the behavior of particles to the movements of galaxies, the same mathematical symmetries emerge. The laws that govern falling apples also guide the orbit of moons. The cosmos seems not chaotic, but composed, its silence filled with reason, its distance illuminated by rhythm. Seeing that symmetry reframes our place within it, we become echoes of its order rather than exceptions to it. Cosmologists began to describe not only what the universe is but how it feels. The language of space turned lyrical, expansion as breath, gravity as embrace, entropy as fading memory. Numbers alone could not express the wonder of finding harmony in the cold. The scientific and the poetic became companions, each translating the other. Through this blending of reason and reverence, a new kind of understanding emerged, one that sees knowledge not as conquest, but as communion. Perspective, in its truest sense, is relational. It depends on distance, contrast, and time. As our instruments reached farther, our view of ourselves deepened inward. The pale blue Earth suspended in darkness became an icon of that awareness. From that vantage, every boundary, every war, every ambition seemed weightless against the backdrop of infinity. The cosmic perspective was not meant to diminish the human, it was meant to soften it, to make it gentler, more attuned to the preciousness of the moment. Einstein's relativity further dissolved the illusion of separation. Space and time, once thought to be independent, merged into a single continuum. Motion became relative to the observer, and gravity turned out to be the curvature of spacetime itself. This realization blurred the line between perception and structure, showing that even time flows differently depending on where we stand. The shift in perspective was not metaphorical, it was physical, woven into the way the universe truly behaves. From this understanding came a new humility about knowledge itself. No observer can see the whole, every measurement carries context. The universe is not viewed from above but from within. Its truths are relational, not absolute. To know something is to interact with it, to share a moment in its unfolding. Even light, the messenger of the cosmos, is bound by finite speed, reminding us that every sight we see is already a memory, a glimpse of the past dressed as the present. This temporal awareness reshaped our understanding of history. The night sky is not a map of now, but a collage of then. Some stars we see have long since died, their light still on its way across the void. Every photon carries with it the record of a vanished moment. In this way, looking outward became an act of time travel. The further we gaze, the deeper into the past we reach, until we see not stars, but the very afterglow of creation itself. As the cosmic story unfolded, dark matter and dark energy entered the stage, forces unseen yet undeniable. They reminded us again that perception is limited, that most of existence is hidden from our senses. The visible universe, all we can observe, is but a faint shimmer on the surface of an unseen ocean. This awareness was humbling but liberating. It meant that mystery is not an absence of understanding, it is the natural texture of reality. The shift continued inward. Physicists, tracing the origins of matter, found that the same particles composing stars also form us. The carbon in our bodies, the calcium in our bones, the iron in our blood, all forged in stellar furnaces long extinct. When stars died, they scattered their contents into space, enriching new worlds to come. We are, quite literally, the dust of the cosmos made conscious. This realization turned astronomy into autobiography. And yet, even as we traced our ancestry to the stars, the scale remained overwhelming. The universe is vast beyond comprehension, and our lives brief as sparks. But perspective softened that contrast. To be small is not to be insignificant, it is to be precise, to be local within the infinite. Every consciousness is a point of awareness within a universe too large to ever fully know itself. Each of us is a small lens through which the cosmos glimpses its own depth. Time, too, revealed itself as relative not only in physics but in feeling. Cosmic time moves in billions of years, but our hearts measure moments in breaths. When these scales overlap, when we see a galaxy through a telescope or hear the whisper of the Big Bang's afterglow, our sense of time stretches. For a moment, we exist across scales, the eternal and the fleeting intertwined. It is in that sensation that wonder resides. With this deeper awareness came a quiet ethics. To understand that everything shares a single origin invites compassion. The atoms that make up our bodies once belonged to stars, comets, and clouds of gas. They have traveled across time, shared between countless forms. We do not merely exist in the universe, we are continuous with it. This continuity asks of us not dominion, but care, not ownership, but awe. In the language of modern cosmology, the universe is isotropic and homogeneous on large scales, uniform in every direction. Yet within that sameness lies the infinite variety of form. Galaxies swirl, stars pulse, and planets bloom with complexity. The lesson is quiet but profound. Unity does not mean monotony. The cosmos finds beauty in variation. Perspective teaches us to hold both truths at once, the oneness and the diversity, as complementary, not contradictory. A further shift comes when we stop imagining ourselves as separate observers. The universe is not out there, it is right here, within every cell, every vibration of thought. The boundary between the self and the cosmos begins to dissolve. We breathe atoms that once drifted between the stars. The light that warms our skin is ancient, having crossed oceans of time. When seen from this view, the cosmos ceases to be a spectacle and becomes a homecoming. Even the silence between galaxies takes on meaning. It is not emptiness but potential, the pause between cosmic heartbeats. In that silence lies the continuity of everything, the quiet assurance that even expansion is part of balance. The stars may drift apart, but the laws that bind them endure. The universe is not a frozen picture, it is an ongoing rhythm, and we are notes within its music. Human perspective continues to evolve. Artificial eyes now gaze farther than any human could, capturing light from before there were stars. Quantum computers and gravitational wave detectors probe the universe not with sight, but with sound and vibration. Each new instrument shifts how we perceive reality, expanding our senses beyond the human scale. With each discovery, our role changes, not as conquerors of knowledge, but as translators of the unknown. Eventually, this shift brings peace. To live within a universe both infinite and knowable in part is to accept both wonder and limitation. We will never see its end or its beginning in full, yet. The act of seeking binds us to it. The cosmos, in revealing its depth, invites us to surrender the need for mastery and embrace participation instead. We are not above the fabric of the universe, we are threads within its weave. Perhaps the most profound change is emotional rather than intellectual. When one truly grasps that every moment, every breath, is a continuation of cosmic history, the ordinary becomes sacred. A beam of sunlight, a ripple of water, the pattern of leaves in wind, all are reflections of the same underlying laws that govern galaxies. Perspective shifts from seeking meaning beyond the world to finding it within. In this new awareness, time itself becomes gentler. The future and past cease to feel like walls but become part of a flowing continuum. The universe, once feared for its vast indifference, begins to feel like an extension of thought, a mind vast and calm, dreaming in equations and starlight. We are among its fleeting dreams, yet in each consciousness, the universe briefly becomes aware of its own existence. And so, the gentle shift in perspective completes its arc. The cosmos is no longer merely something to study, it is something to feel. Its expansion mirrors our own capacity for understanding, its darkness mirrors the spaces within us where thought takes shape. To look at the night sky is to look into a reflection of our own becoming. The shift is not grand or sudden, it is quiet, slow, and infinite, like the universe itself unfolding one breath at a time. In the soft afterlight of discovery, when the known has been carefully mapped and the unknown still hums beyond reach, a new idea begins to take form. It does not announce itself with thunder but with a flicker, like a thought half remembered or a star seen at the edge of vision. The new idea begins to glow not as a conclusion, but as a question luminous enough to change everything it touches. It stirs beneath the surface of the universe's calm, whispering that perhaps what we know is only the outline of something far more intricate and alive. The glow begins quietly, in the minds of those who listen rather than claim. It rises from doubt, from the spaces where equations don't quite align, where light bends a little more or less than expected. The idea that the universe may not be what it appears has never truly faded, it only waits for language to catch up. Every century, it finds new expression, new courage, and new thinkers willing to step into the half-light between science and imagination. That is where all revolutions begin, not in certainty, but in curiosity illuminated by wonder. As astronomers and physicists peer deeper into space, they see not only galaxies but patterns, rhythms in the darkness. Expansion is not just speeding up, it may be uneven, perhaps rippling in ways unseen. Quantum theory hints that vacuum energy is unstable, that fluctuations could spawn new regions of space entirely. The glow of the new idea takes shape here, that the universe might not be a single, simple whole but a living process, constantly birthing realities within itself, each governed by subtle variations of the same cosmic law. It is difficult to define such an idea, for it does not yet have borders. Some call it the multiverse, others the landscape of possibilities, or the quantum foam of creation. Yet beneath all names lies one truth: the universe may not be content with stillness. It may be infinitely creative, never finished. The glow of this thought spreads slowly, igniting not only scientific debate but a deeper shift in how we perceive existence. It suggests that creation is not a past event but a continuous act, unfolding everywhere and always. In laboratories and observatories, instruments now hum to catch the faintest whispers of these deeper layers. Physicists analyze the cosmic microwave background for irregularities that could betray collisions between universes, while quantum theorists explore vacuum decay and the birth of new spacetime domains. Each new piece of data either sharpens or softens the glow, but never extinguishes it. The idea endures because it feels inevitable that creation cannot be singular, that existence itself might be a fabric woven from countless interwoven threads of being. The glow expands into philosophy. If the cosmos is truly plural, if reality itself branches endlessly, then every possible configuration of matter, energy, and even thought might find form somewhere. This does not make our world less meaningful, it makes it more precious. For amid infinite variation, this precise pattern, this sequence of stars, this planet, this moment still exists. The glow of the new idea is not cold or abstract, it is intimate, for it reminds us that even in infinity, what is here and now remains unique. Some scientists resist this notion, preferring the solidity of the observable. They argue that what cannot be tested may not be science at all. Yet the glow persists, because curiosity itself is luminous. It cannot be contained by definition. The history of knowledge is full of ideas once thought untestable that later reshaped the world: gravity, atoms, relativity, dark matter. Each began as a glow, dismissed as speculation, until new tools brought its light into focus. Perhaps this, too, will follow that pattern. From dream to data, from wonder to law. The glow reaches the edges of cosmology, where mathematics and imagination merge. Equations describing inflation suggest that space may eternally self-replicate, each new bubble universe expanding and stabilizing with its own constants. Some might be lifeless, others blazing with strange forms of matter and time. Our own, perhaps, is one among countless others drifting through an ocean of space-time. If so, then what we call the universe is merely a local region of something infinitely larger, a single flame in an eternal field of light. This perspective does not diminish us. Instead, it deepens the meaning of our awareness. To be conscious in such a universe is to hold within one mind the recognition of both vastness and intimacy. The glow of the new idea reminds us that knowledge does not end with what we can see. It extends into what we can imagine with discipline and care. It invites humility, the kind that accepts mystery as a companion rather than an obstacle. The more we learn, the more delicate the glow becomes. It is not blinding, it is soft, like starlight filtered through cosmic dust. It reveals that existence itself might be recursive, that patterns repeat across scales, from the quantum to the galactic. The dance of electrons around a nucleus mirrors the orbit of planets around stars. Perhaps consciousness, too, follows a similar rhythm, arising whenever complexity reaches a certain threshold. The glow then becomes both cosmic and personal, connecting our inner awareness to the universe's unfolding form. At the frontier of quantum mechanics, the new idea flickers brighter. The observer effect, the notion that measurement influences reality, suggests that potential and actuality are intertwined. The universe is not simply observed, it is co-created by observation. Each act of perception solidifies one possibility among many. The glow of this realization is profound. Consciousness might not be separate from the cosmos but an essential participant in its ongoing creation. The universe, through awareness, comes to know itself. The glow is not confined to science alone. Artists, poets, and philosophers sense it too, weaving its implications into their work. They see in it a metaphor for renewal, for the endless birth of perspective. If the cosmos creates endlessly, so too can the human spirit. The creative act becomes a reflection of cosmic behavior, the making of something new out of the potential that surrounds us. Every thought, every work of art, every expression of kindness becomes an echo of the same law that shapes galaxies. As understanding deepens, boundaries blur. Physics begins to sound like metaphysics, and metaphysics begins to echo physics. What was once divided, mind and matter, observer and observed, energy and form, starts to converge into a unified vision. The glow of the new idea softens these distinctions without erasing them, reminding us that duality is a language of perspective, not of reality itself. The cosmos might not be made of things at all, but of relationships, connections that shimmer and shift like threads of light. Meanwhile, the dark energy that drives the universe's acceleration grows in importance. It may hold the key to understanding this deeper fabric. Perhaps dark energy is not a substance but a property of space's continual renewal, a signature of creation still at work. In that case, the universe is not running down but transforming, always birthing new possibilities. The glow of the idea expands once more, suggesting that even entropy may be a form of evolution, a dispersal that allows new structures to arise elsewhere. The cosmic web, when mapped, reveals structures reminiscent of living systems. Filaments resemble neural pathways, clusters resemble synapses, and the distribution of galaxies mirrors patterns of thought. Though the comparison is metaphorical, it raises an unsettling and beautiful question. Could the universe itself be a kind of consciousness? Not in the human sense, but as an emergent awareness arising from its vast complexity. The glow brightens here, for the idea blurs the line between observer and observed until they become one. Yet, as always, every new glow casts new shadows. If the universe continually gives birth to itself, then the question of origin becomes less clear. Was there ever a beginning, or is the act of creation timeless, without boundary? The idea suggests a universe not born from nothing but from transformation, a cycle with no first moment, no external cause, only an infinite self-organizing flow. The glow of such a notion is both comforting and dizzying, freeing us from the need for a single answer while offering endless wonder. For the first time, scientists and philosophers find themselves united in uncertainty rather than division. The language of mathematics becomes poetry, the poetry of or becomes theory. What was once dismissed as mystical begins to resonate with quantum and cosmological insight. The glow bridges these realms, showing that the pursuit of truth is not linear but circular, spiraling outward through deeper layers of the same mystery. The more we know, the more luminous our ignorance becomes. Humanity, standing on a small planet under ancient stars, finds comfort in this glow. It tells us that the universe is not static or indifferent, it is creative, adaptive, alive in its own way. We belong to its unfolding not as accidents but as expressions of its potential. Every thought, every heartbeat, is part of the same process that lights the stars. To sense this connection is to glimpse the sacred without invoking divinity, a quiet reverence for the order and chaos that coexist in perfect measure. The glow of the new idea also changes how we think of time. Perhaps time itself is not a single river but a network of streams, branching and rejoining in countless directions. The past and future might coexist, woven into the same quantum tapestry. If so, then every moment we live radiates outward, influencing not just what will be, but what already was. The glow becomes temporal as well as spatial, illuminating the strange symmetry of existence. In the hearts of thinkers and dreamers, this idea becomes fuel for imagination. Science fiction begins to sound less like fantasy and more like hypothesis. The boundaries between what is and what could be grow porous. The glow does not destroy reality, it deepens it, expanding its dimensions. Every discovery we make about the cosmos reminds us that the world we inhabit is not fixed but continually rewriting itself. The universe is a book that never closes. And as we continue to explore, we begin to realize that the glow has been with us all along. It is the same light that inspired ancient stargazers, the same curiosity that led to fire, tools, and language. The new idea, however novel, is part of an ancient continuity, the human desire to find coherence in the infinite. The glow that begins as thought becomes heritage, linking generations across time through shared wonder. As technology reaches further, as our instruments detect the faintest patterns of gravitational waves or cosmic dust, the glow sharpens into detail. It reveals a universe more intricate than anyone imagined, filled with invisible structures, quantum echoes, and fields that intertwine like threads in an endless loom. Yet for all this complexity, the feeling remains simple: awe. The glow is not just intellectual illumination, it is emotional warmth, the quiet joy of understanding something vast enough to humble and elevate at once. Perhaps the new idea is not merely about the universe but about us, how we perceive, connect, and evolve. Every expansion of understanding mirrors an expansion within the mind. The glow that begins in equations ends in empathy, teaching us that everything we study reflects something within ourselves. The cosmos, it seems, is not distant, it is inward, woven through the patterns of thought and breath that animate us. To study it is to rediscover ourselves in infinite form. The glow deepens as we accept that truth may never be final. Each answer gives rise to new questions, each discovery opens new unknowns. The pursuit itself becomes the purpose. The universe, endlessly unfolding, invites us not to finish the story but to participate in its telling. The glow is the reminder that knowledge is not a possession but a relationship, a dialogue between the finite and the infinite, the seen and the unseen. Eventually, the glow settles into something quieter, like embers at the edge of night. It does not fade, it steadies. The new idea becomes part of the cosmic language, a phrase added to the ongoing conversation between humanity and the stars. Whether or not it proves true in the strictest sense, it has already changed us by widening our imagination. The glow becomes wisdom, a way of seeing that joins humility with wonder, precision with poetry. And so, the glow continues, soft, patient, enduring. It lingers in laboratories, in observatories, in silent nights when one looks up and feels both infinitely small and deeply known. It is not just an idea now, but a feeling, a recognition that the universe is unfinished, that we are part of its ongoing thought. Every discovery adds a spark, every insight another hue. The glow of the new idea is the universe awakening to itself again, through us, across the endless dark. In the beginning, before stars, before even the notion of time as we understand it, there were ripples. They were not waves upon water, but gentle tremors within the fabric of space-time itself, minute fluctuations born in an ocean of energy so dense it defied all language. These ripples carried the faint signature of everything that would one day exist: galaxies, light, life, thought. Each was a whisper of imbalance, a deviation so small it seemed almost nothing. Yet in that near-nothingness lay the blueprint for all creation to come, vibrating softly in the darkness before dawn. As the universe expanded, those ripples stretched and grew, imprinted upon the cosmic background like ancient fingerprints. The radiation that fills the sky today, what we call the cosmic microwave background, is their afterglow, the faint echo of their motion. Every point of brightness and shadow within that pattern marks a difference in density, a place where matter gathered or thinned. Over billions of years, gravity would take those faint irregularities and sculpt them into the grand architecture of the cosmos, clusters of galaxies, cosmic voids, and the vast filaments that bind it all together. Scientists look upon this ancient light as a kind of message from the past, frozen when the universe was barely 380,000 years old. It is the oldest photograph ever taken, though it was not captured by camera but by mathematics and detection. When we map those ripples, we see the universe as it once was, a hot, glowing fog of plasma, humming with potential. The patterns are astonishingly uniform, yet not perfect. That imperfection is everything. Without those small asymmetries, the universe would have remained a smooth, featureless expanse, too balanced to ever give birth to stars. Those early ripples are not merely relics, they are the reason structure exists at all. They reveal how randomness can become order, how chaos, under the right conditions, leads to beauty. Inflation theory, the idea that the universe underwent a sudden burst of exponential expansion in its infancy, suggests that quantum fluctuations were stretched across cosmic scales, seeding those very ripples. What began as the jitter of subatomic uncertainty became the scaffolding for galaxies. In this way, the smallest scales of existence shaped the largest. Each ripple carried within it the memory of its birth, encoded in frequency and amplitude. Scientists decode them as if reading the heartbeat of creation. The Planck and WMAP satellites have traced their contours with exquisite precision, revealing a cosmos both simple and profound. The data aligns elegantly with the story of inflation, yet leaves room for mystery, small anomalies, cold spots, and alignments that defy easy explanation. These might be cosmic coincidences, or perhaps subtle hints of deeper physics still waiting to be uncovered. Some theorists suggest that these anomalies could even be scars, places where our universe brushed against another during its earliest moments. If true, then the ripples we see are not just from our own beginning but from interactions beyond our cosmos. The thought is staggering, that the faint unevenness in the microwave background might be the signature of a greater multiverse, where each universe leaves impressions on others like waves colliding across an infinite sea. Such possibilities blur the boundary between physics and philosophy, where imagination becomes a legitimate tool of inquiry. Even without such grand speculation, the ripples remind us that perfection is not the source of creation, imperfection is. A flawless beginning would have produced nothing but silence and symmetry. It was the tiny irregularities, the uneven hum of the early universe, that gave rise to the complexity we now see. In that sense, existence itself owes its richness to asymmetry. The stars, the planets, the people all descend from those primordial ripples that refused to be uniform. In their unevenness, the cosmos found its voice. Every measurement of those ripples is also a measurement of time itself. Light from that early epoch has traveled nearly 14 billion years to reach us. When we detect it, we are not merely looking far away, we are looking far back. The photons have crossed the expanding void, stretched into microwaves by the universe's growth, carrying within them the soft memory of heat and sound. To observe them is to hear the echo of creation's first breath, faint yet constant, surrounding us from every direction. Cosmic inflation theory predicts that those early ripples should have generated gravitational waves, faint distortions in spacetime itself. Detecting such primordial waves has become one of the great quests of modern physics. In 2014, scientists thought they had found them in the BICEP 2 experiment, but later analysis revealed the signal was mostly cosmic dust. Still, the search continues. If these gravitational ripples were ever confirmed, they would be direct proof of the universe's earliest, most explosive moment, a glimpse into the heartbeat of the Big Bang itself. The idea that something as intangible as a ripple could shape everything we see may seem abstract, yet the evidence is all around us. Every galaxy is a fossil of those early patterns, every cluster a memory of quantum tremors stretched by expansion. The web of cosmic structure is a frozen dance of those vibrations. It is humbling to realize that everything solid, mountains, oceans, human beings, emerged from waves in an invisible medium, oscillations that no longer exist but whose echoes define our reality. Astronomers describe these ripples in statistical terms: power spectra, temperature anisotropies, polarization modes, but behind the data lies a deeply poetic truth. The universe began not with form, but with music. The ripples were the first song, a resonance that continues to this day in the silent hum of cosmic radiation. We are, in a very real sense, shaped by that ancient melody. The matter that forms us once moved with the rhythm of creation's earliest vibrations, and in that continuity lies a profound connection to everything. When we look at those faint fluctuations, we are reminded that even the smallest disturbances can change everything. A tiny variation in density led to the birth of galaxies. A slight imbalance in temperature became the difference between light and darkness. From these microscopic beginnings, time unfolded into complexity. Perhaps, then, the universe is not simply vast, it is sensitive. Its entire history turns on the delicate balance between chaos and harmony, each ripple a note in a composition still being played. In studying these ripples, cosmologists have learned more than just the structure of the universe, they have learned how to listen. The sky becomes not just an image but a soundscape, one that speaks of age, expansion, and potential. Even now, new instruments attempt to measure the polarization of the cosmic microwave background with greater precision, searching for signatures that might reveal how matter and antimatter first diverged. Each new discovery brings us closer to the instant before the first light, an impossible, almost sacred pursuit. The ripples also remind us that beginnings are never as violent as they sound. The term Big Bang conjures an explosion, but the reality was quieter, a vast, uniform swelling of space itself, governed by simple laws. The ripples were its first imperfections, small deviations growing into the immense diversity we now inhabit. The story is one of gentleness amplified by time, where the faintest shiver becomes the architecture of all being. In that sense, creation was not a shout but a whisper that never stopped echoing. Across time, those ripples stretched into waves of influence. The gravitational pull of dense regions attracted more matter, while sparse regions became voids. Over billions of years, galaxies formed where the waves overlapped most strongly, like foam gathering on the crest of a tide. The cosmic web today, its filaments, clusters, and gaps, is the fossilized surface of that ancient sea. The ripples did not disappear, they froze into form, transforming vibration into geometry, sound into structure. Our own Milky Way was born within one of those ripples, a condensation of matter tracing back to that early cosmic music. Every star, including our Sun, every planet, including our Earth, and every molecule, including the ones composing you, are descendants of that primordial rhythm. When you breathe, when your heart beats, you echo the same wave that first trembled through space-time. The connection is not metaphorical, it is physical, etched into the very atoms that make up your body. In a sense, the universe still ripples. Dark energy causes its expansion to accelerate, and gravitational waves continue to ripple through space-time, the aftershocks of colliding black holes and merging neutron stars. But these modern ripples are smaller, fainter, localized echoes of that first cosmic vibration. They remind us that the universe is still alive, still moving, still murmuring to itself in the low language of space-time distortion. Creation, it seems, is an ongoing conversation, not a finished statement. Some have wondered if the early ripples carry hidden messages, mathematical symmetries, or patterns beyond random chance. So far, no clear signal has emerged, yet the idea persists. Could the universe's earliest light contain encoded information, perhaps evidence of deeper dimensions or intelligence woven into the laws of physics? The thought is speculative but not absurd. If reality is mathematical, then the cosmic microwave background may be the most ancient inscription of that code, written not in words but in temperature variations measured in microkelvins. The ripples also reveal something about fragility. The balance of forces in those first moments was so delicate that a slightly different ratio between matter and radiation could have led to a barren cosmos or one that collapsed immediately. That we exist at all is testimony to precision on a cosmic scale. The ripples were tuned perfectly, not by design, perhaps, but by necessity, shaped by laws that permit complexity to emerge from simplicity. In that balance lies a quiet kind of grace. Each generation of scientists refines the picture further, reducing uncertainty, uncovering subtler variations. Yet for all their precision, what they chase remains an echo, a whisper fading across time. The light of the early universe is ancient beyond comprehension, and as space continues to expand, it grows fainter still. One day, far in the future, even that background radiation will stretch beyond detectability. The ripples will persist, but only as memory encoded in whatever minds still look up and remember. But memory itself is a kind of ripple, waves within consciousness that reflect the universe's first motion. Perhaps our capacity to recall, to imagine, to dream, is a faint mirror of that same process. Patterns arising from noise, meaning emerging from chaos. The mind, like the cosmos, is not built from matter alone but from vibration and resonance. We are, at every scale, beings made of waves, carriers of continuity from the first trembling of existence. It is humbling to realize that everything we know about the early universe comes not from direct observation but from interpretation, from light, data, and equations that we translate into understanding. Yet in those translations lies a kind of artistry. The universe gives us fragments, and we build from them a story. The ripples, faint as they are, become our greatest teachers. They show that the past is not lost, it is written everywhere, waiting to be read by those patient enough to listen. Even as we measure these ancient tremors, we are adding our own. Every experiment, every act of inquiry, sends new ripples through the realm of thought. Human curiosity is itself a continuation of the same process, fluctuations growing, colliding, creating new forms of order. In this way, the universe has found a way to study itself. The ripples that once shaped galaxies now move through minds, through questions, through the desire to know. The more we understand these ancient patterns, the more they teach us about humility. We are not the center of the story, we are one of its consequences. The ripples remind us that beauty arises from balance, that fragility and imperfection are the soil of all creation. Even now, as telescopes reach further into time, the lesson remains unchanged. From the smallest vibrations come the grandest structures, and from silence comes the song of existence itself. In the quiet hum of background radiation, we can almost hear it still, the faint echo of the universe learning how to become. It is not a sound in the ordinary sense, but a memory made of light, a pattern of warmth scattered across infinity. The ripples continue, expanding through both space and understanding. They whisper that nothing ever truly ends, only transforms, and that even the faintest tremor can shape eternity. In the vast stillness of cosmic time, we have always imagined the laws of physics as fixed, unwavering, like the pillars of some eternal temple. Gravity, light, motion, and energy, these seemed not just consistent, but sacred, the foundation upon which all existence rests. Yet the deeper we look, the more that certainty begins to waver. What if the laws themselves are not eternal? What if they, too, evolve, shift, or transform over cosmic epochs? The thought is unsettling, yet strangely alive, as though the universe were not a machine, but a living organism learning its own rhythm. Early cosmologists assumed the universe operated like a grand clockwork, its gears and cogs moving predictably, wound once by the Big Bang and left to tick forever. But as our understanding deepened, cracks appeared in that vision. Constants like the speed of light, the fine structure constant, and even the strength of gravity seemed too precise, almost suspiciously tuned for the existence of life. Some began to ask, what if these constants are not constant at all, but snapshots, values that have changed, or could change, as the universe unfolds? The concept of changing physical laws did not emerge easily. It challenged everything we thought we knew about science itself, where predictability and repeatability are cornerstones. But the cosmos is not a laboratory, it is history written in energy and expansion. Evidence began to surface in subtle forms, shifts in atomic spectra from ancient light, possible variations in the ratios that govern electromagnetism. These were not definitive, but they opened a door to an idea once considered impossible, that even the laws that define the universe might themselves be products of evolution. If true, such evolution would not be random chaos. Rather, the laws might shift in response to the universe's own conditions, adapting like biological traits. As space expands and matter thins, as time stretches and energy cools, the underlying relationships between forces could alter slightly, like notes in a melody played slower with age. In that sense, the cosmos would not just change in content but in character, its very rules rewriting themselves as new possibilities emerge from old patterns. Imagine a universe where gravity was once stronger, pulling matter together more tightly, allowing stars to form faster and burn brighter. Over eons, as expansion continued, gravity might have weakened, allowing galaxies to drift apart more freely, shaping the large-scale structure we see today. Similarly, the charge of an electron or the ratio of mass between particles could have shifted imperceptibly, creating different eras of physics, each with its own version of balance and stability. The cosmos, then, would be a narrative of changing symmetries. Some physicists have proposed that constants like the fine structure constant, which determines how strongly light interacts with matter, might have varied across billions of years. Observations of distant quasars suggest minute differences in their light signatures, as if the electromagnetic force was once slightly different. Though debated and uncertain, the idea persists because it fits a broader intuition, that the universe, vast and dynamic, may not be content to obey fixed rules forever. Perhaps its constants are more like habits, enduring, but not immutable. The implications are profound. If physical laws can evolve, then so can the conditions for life, structure, and even thought. In some regions of space, or in earlier cosmic epochs, different combinations of forces might have produced entirely different realities. Stars might have burned differently, chemistry might have followed new paths, and consciousness, if it arose, might have perceived existence through different senses of order. The universe would not be a singular reality but a vast experiment in variation, unfolding through time. Such a notion brings an unsettling kind of freedom to the cosmos. It means that there was no fixed design, no predetermined script written at the beginning of time. Instead, creation might be improvisational, a process of trial, adaptation, and transformation. The universe learns through its own unfolding, testing combinations of energy and structure until something stable emerges. We, as observers within it, are part of that ongoing experiment, momentary witnesses to one of its current configurations. This idea also bridges science and philosophy in unexpected ways. If the laws of nature are not eternal, then perhaps they arise from something deeper, a meta-law, a principle of self-organization that governs how laws themselves emerge and evolve. Some theorists call this the cosmic selection hypothesis, that universes reproduce through black holes or quantum fluctuations, each new universe inheriting slightly modified constants from its parent, like traits passed down through cosmic generations. The multiverse, then, would not just be a collection of random bubbles, but an evolutionary lineage of laws. In this framework, universes that produce more black holes or more complex structures become more fertile, creating offspring with similar but slightly varied parameters. Over eons, natural selection operates not on creatures but on the fabric of reality itself. Those universes with stable physics and long-lived stars persist and multiply, others fade quickly into silence. It is a breathtaking thought, that the very existence of our world may be the result of a long ancestry of cosmic experimentation, where stability and creativity find balance across infinities. If that is true, then constants are not constants but records, the inherited features of cosmic evolution. And like biological evolution, these changes may occur so slowly and subtly that from our brief perspective, they appear fixed. Yet across trillions of years, the universe's genetic code of physics may drift, exploring new variations. Even the concept of time could transform if the laws that define it shift. The universe might not merely age, it might metamorphose, becoming something qualitatively new. Some thinkers have dared to suggest that this slow evolution could even have purpose, not in a mystical sense, but as a natural tendency toward increasing complexity. Systems that sustain energy flow and information, such as stars, galaxies, and minds become the engines of that complexity. Perhaps the universe evolves toward greater self-awareness, each epoch birthing new forms of perception. In such a view, consciousness is not an accident of physics but an inevitable flowering of its evolution, the cosmos awakening to itself through its own changing rules. Even if this seems speculative, it resonates with what we observe. The laws of physics describe simplicity giving rise to complexity, hydrogen forming stars, stars forging heavier elements, those elements building life, and life generating thought. Each step is a transformation of what was once basic into what becomes capable of reflection. A universe with changing rules would simply extend that story further, suggesting that the potential for new forms of existence is never exhausted, that the script of reality keeps rewriting itself endlessly. To those who find comfort in fixed order, the idea may sound chaotic. Yet there is a deeper order within change itself, a rhythm that persists even as the tune evolves. Just as music relies on variations to sustain beauty, the universe's shifting rules may be what allows it to remain fertile, creative, alive. Static perfection would be sterile. Dynamism breeds diversity. The cosmic story is not about permanence but about continuity through transformation, the art of becoming rather than simply being. Some scientists have begun to look for direct evidence of this transformation, measurements of ancient starlight, gravitational lensing, and fine structure variations across cosmic time. So far, the data remains inconclusive. The universe guards its secrets well. But even the pursuit itself is meaningful. It forces us to ask not only what the laws are, but why they are, and whether they could be otherwise. In that questioning lies the truest form of wonder, not the search for certainty, but the willingness to see reality as dynamic. In a universe where rules evolve, time itself becomes a creative force rather than a passive flow. Each moment is not merely a continuation of the last, but a redefinition of what is possible. The future is not constrained by the past, it is an open canvas. Such a vision brings hope even to human life, suggesting that change is not decay but renewal, that even as stars burn out and galaxies drift apart, new forms of order may arise, new patterns of being shaped by new laws. As the universe ages, its energy thins and its temperature drops. Yet within this cooling, new physics may emerge. The vacuum of space, once thought empty, might shift in nature, revealing different quantum behaviors. Dark energy could evolve or decay, altering the course of cosmic expansion. The universe's fate, once predicted as eternal freeze or collapse, may instead be far stranger, a sequence of transitions, each governed by a new set of principles, each birthing a fresh mode of existence from the ashes of the last. If the laws are mutable, then even death may not be absolute. Black holes could give rise to new universes through quantum tunneling, their interiors blooming into separate realities with altered rules. What seems like destruction from one perspective could be creation from another. The cosmic cycle would thus continue indefinitely, endings becoming beginnings, constants becoming variables, and order perpetually reborn through transformation. This possibility reframes the human role in cosmic history. We are not passive observers of fixed laws but participants within an evolving narrative. Every discovery we make, every equation we refine, extends the universe's self-understanding. Perhaps even our act of observation influences how reality unfolds, subtly shifting the balance of probabilities in a cosmos still learning how to be. We are, in a quiet but profound sense, collaborators in the ongoing invention of existence. To imagine a universe with changing rules is to imagine a cosmos that breathes. It expands and contracts, cools and ignites, rewrites and redefines itself in cycles of infinite experimentation. Each age carries echoes of the one before, yet none are identical. The laws we measure today are not errors nor absolutes, but expressions of a particular cosmic moment, like the tone of a song that will soon modulate into another key. And perhaps, somewhere beyond our reach, other regions already hum with different harmonies. In such a vision, permanence becomes an illusion, but meaning deepens. The universe is not bound by rigid constraints but guided by a deeper principle of creativity. Even decay becomes transformation, even silence becomes preparation for new sound. Change is not the loss of order but its evolution. The laws are not commandments but conversations, dynamic relationships between matter, energy, and possibility. Through them, the cosmos speaks in the language of adaptation, not obedience. This evolving universe may one day transcend even its own foundations. The constants could shift beyond recognition, matter could dissolve into patterns of pure information, and the distinction between energy and consciousness could blur entirely. If that happens, the cosmos may not end but awaken, transitioning into a new phase of being beyond physics as we know it. The rules we follow today would then be remembered as the childhood of reality, the first grammar of a language still expanding into eternity. For now, we remain in the middle of that unfolding story, standing between what was and what will be. We measure, we wonder, we argue, but beneath it all, we feel the motion of something vast, not a static truth but a living process. The universe is changing, and perhaps its rules are learning. Adapting, singing in new frequencies. Every equation, every observation, is a translation of that song, rendered in numbers instead of notes. And maybe that is the quiet lesson these possibilities offer, that nothing, not even the laws of nature, is ever truly fixed. All things, from galaxies to gravity, from atoms to awareness, are part of one long improvisation. The universe is not a completed symphony but an evolving one, adding new movements as it goes. To exist within it is to be part of that change, to witness, to shape, and to be shaped by the grand, restless unfolding of the cosmos itself. In the end, perhaps the rules of the universe are not laws at all, but memories, habits carried forward from one era to the next, flexible enough to allow growth, firm enough to preserve continuity. They evolve, and through them, so does everything else. The story of reality is not about constancy but metamorphosis, not about control but participation. We are living in the middle of a great experiment where even the experimenter, the universe, is learning what it can become. The thought is humbling, yet comforting. For if the rules can change, then nothing is final, not decay, not loss, not even the end of time. The cosmos is a work in progress, eternally revising itself. And perhaps, in its vast and unending transformation, it carries within it the quiet assurance that everything, every star, every thought, every fleeting life, contributes to the grand rewriting of the universe's endless, evolving song. Far across the fabric of space, galaxies drift like lanterns floating on an unseen tide. Each one holds billions of suns, billions of stories, and yet when viewed together from a cosmic distance, they move with a serenity that seems almost choreographed. Their slow spiral turns and graceful collisions unfold over billions of years, too vast for human senses to perceive directly. Theirs is not a violent waltz, though energy rages within, it is a quiet, eternal dance written into the rhythm of space itself, echoing the expansion of the universe that birthed them. Galaxies are not scattered randomly. They gather in clusters, threads, and sheets, great filaments stretching across the cosmic web. Between them lie enormous voids, empty spaces where few stars exist, silent intervals in the symphony of the cosmos. These structures form the universe's grand architecture, sculpted by gravity's patient hand. It is a kind of slow choreography, where attraction and motion intertwine, creating forms so immense that they challenge the mind to comprehend them. When a galaxy forms, it is like a swirl of memory. Gas and dust collapse under their own weight, igniting stars that light the darkness. Over eons, these stars orbit a common center, tracing luminous spirals or soft ellipses. In time, the galaxies evolve, some merge, some are torn apart, some fade into faint remnants. Yet through all this, the pattern of their motion remains curiously elegant, as if the universe prefers beauty even in chaos. Every orbit, every rotation, whispers of an underlying harmony that persists across billions of years. The dance is slow, deliberate, and unending. Two galaxies may begin to draw toward each other over hundreds of millions of years, their shapes distorting as tides of gravity pull at their arms. What looks from afar like collision is in truth a long embrace, where stars rarely touch but their paths weave together, creating bridges of light. Sometimes, from that merger, a new galaxy is born, larger, calmer, its stars redistributed into a more tranquil form. It is creation through surrender, destruction through grace. Our own Milky Way is a dancer in this cosmic ballet. It spins silently, its spiral arms stretching tens of thousands of light-years, home to uncountable suns. Around its edges drift smaller galaxies, companions drawn into its gravitational influence. And far away, the Andromeda Galaxy approaches, inching closer every year. In about 4 billion years, they will merge, their stars passing through one another like ghosts, their shapes melding into a single, radiant form. What we call an end will merely be the next movement in the universe's quiet choreography. Within each galaxy lies a hidden rhythm, the balance between gravity pulling inward and motion pushing outward. This equilibrium keeps them stable, shaping spirals and ellipses that persist for ages. Yet beneath that balance lies tension. Dark matter, invisible but vast, gives galaxies the weight needed to hold themselves together. Without it, they would spin apart. It acts as the unseen partner in this dance, guiding their movements, anchoring their elegance, though it never reveals its face. If we could listen instead of see, galaxies would sound like low, deep music. Their motions, spread across time, would create a hum of frequency far too slow for human ears. Every cluster and orbit would contribute a note, each merging event a resonant chord. The entire cosmos would be an orchestra of gravity and light, playing a composition that began with the Big Bang and will continue until time itself grows still. To perceive it requires patience, not of minutes or years, but of eternity. Galaxies are also storytellers. Their colors and shapes reveal their ages and moods, young blue spirals full of new stars, old red ellipticals glowing with ancient light. Some shine brightly with active cores, powered by black holes consuming gas at their hearts. Others drift quietly, their fires dimmed, their stars fading into the long night. Together, they form the history of the cosmos, a living record of creation, transformation, and decay, written not in words but in motion and radiance. When two galaxies meet, the encounter reshapes them both. Their stars are flung into vast new paths, their gas clouds compressed into bursts of star formation. The process takes hundreds of millions of years, long enough for entire species to rise and fall on planets that might orbit within. To us, such changes are imperceptible, yet they define the evolution of the universe. The slow rhythm of these mergers is the heartbeat of cosmic time, each one adding a verse to the universe's unfolding poem. There is something deeply poetic in how galaxies rarely collide in destruction. The space between stars is so vast that even in the densest mergers, most pass untouched. Instead, gravity reshapes their paths gently, sculpting new patterns. From chaos arises structure, from collision, harmony. It is a profound reminder that even the most dramatic encounters in the cosmos are more about transformation than annihilation, a lesson mirrored, perhaps, in the quieter collisions of human lives. In the early universe, galaxies were small and chaotic, colliding frequently, burning through their gas quickly. Over billions of years, they grew calmer, larger, more structured. The cosmic dance matured, slowing from a wild frenzy into a graceful waltz. Now, the expansion of space stretches them farther apart, reducing the number of encounters. In time, perhaps the dance will quiet completely, each galaxy becoming an isolated island in the growing dark, still spinning, still beautiful, but forever alone. That future stillness holds a strange peace. Long after the last star has faded, galaxies will remain as cold shadows, their structure faint but persistent. The motion will continue even then, though the light will be gone, a silent dance in a universe without witnesses. Yet perhaps that is the true essence of beauty, movement for its own sake, harmony that endures even when unseen. The galaxies will keep dancing, not for observation, but because motion is their nature, their eternal vow to existence. Galaxies also teach us about balance. In their centers lurk black holes of unimaginable density, swallowing light and matter alike. Yet these monsters are not destroyers alone. Their gravitational pull helps shape the very galaxy they inhabit, regulating star formation and maintaining equilibrium. It is as if creation and destruction were partners in the same slow dance, each defining the other's steps, ensuring that no motion becomes meaningless excess. Some galaxies form vast chains across the cosmos, linked by invisible filaments of dark matter. These structures stretch hundreds of millions of light-years, connecting clusters like notes on a staff. Their shapes resemble neural networks, hinting that perhaps the universe itself is a kind of mind, one that thinks in galaxies, not neurons. When we map these filaments, we are tracing the thought patterns of the cosmos, glimpsing its structure not as chaos but as consciousness expressed in gravity. Every galaxy carries a memory of its past within its motion. The orbits of stars preserve echoes of old collisions, ancient flows of gas, and long-vanished neighbors. Astronomers read these motions like archaeologists read layers of stone, uncovering epochs of change hidden in every rotation. A spiral arm stretched here, a warp there, these are fossils in motion, testimonies of encounters billions of years gone. The galaxies remember, even when no one else does. From a distance, the universe looks still. The stars do not seem to move, galaxies appear frozen in their shapes. Yet everything is in motion, drifting, spinning, expanding. Stillness is an illusion born of our smallness. If we could watch for 1 billion years, we would see galaxies swirling like petals in the wind, merging and reforming endlessly. Their calm is only apparent, beneath it lies ceaseless motion, the pulse of creation that never stops beating. There are galaxies so faint that they barely shine at all, ghostly collections of dark matter with only a few stars. These hidden dancers move silently through the cosmic web, unseen partners shaping the visible universe. Though they lack brightness, their gravity still influences the grand choreography, guiding brighter galaxies in unseen patterns. Their presence reminds us that what we see is never all that exists. Most of the universe's beauty lies in its invisibility. As galaxies drift farther apart with cosmic expansion, their light becomes stretched, reddened by time itself. To look at distant galaxies is to look backward, to see them as they were billions of years ago. The light we receive now began its journey before Earth even formed. Each photon carries with it the memory of ancient dances, moments when stars first ignited, when gas swirled into arms, when black holes stirred awake. Observing them is like reading old love letters written by the universe to itself. The dance of galaxies is not random, it is shaped by dark energy as well, that mysterious force accelerating their separation. It is as if the music of their motion has begun to slow, stretched by an unseen tempo change. Over unimaginable spans of time, this expansion may isolate each galaxy completely, leaving them to spin in solitary silence. Yet even then, the memory of connection, the pattern of motion that once bound them, will linger, like the echo of a note long after the song ends. Somewhere, deep in that quiet future, our merged Milky Way Andromeda galaxy will still turn, its stars orbiting a common heart. Its black hole will hum softly, its remaining light scattered among endless dark. Perhaps by then, new civilizations will look upon the sky and wonder if other galaxies ever existed, not realizing they are gazing into the faded traces of an ancient dance. The story will live on in the movement of stars, even when language is gone. We often think of galaxies as distant and unreachable, yet every atom in our bodies was born within them. The carbon in our cells, the iron in our blood, all forged in ancient stars that once danced within those spirals. When we look up at the Milky Way, we are not seeing something foreign, we are seeing our origin, our cosmic family. The quiet dance of galaxies is also our story, our lineage of light written across eternity. Even the smallest galaxies, the irregular ones, follow the same rules, drawn together by gravity, reshaped by time. Their uneven forms and wandering paths remind us that perfection is not necessary for beauty. In their asymmetry lies uniqueness, in their chaos lies creativity. The cosmos does not demand uniformity, it celebrates variation, movement, and change. Every galaxy, no matter how faint, adds its own rhythm to the universal dance. When we observe galaxies colliding in deep space, we see not destruction but transformation. The stars continue, the orbits reform, and new generations of suns arise from compressed gas. It is a dance that ends and begins simultaneously. What once was two becomes one, and what was one becomes the seed for countless new stars. It mirrors the cycles of life itself, endings feeding beginnings, balance emerging from motion. In the farthest reaches of the universe, galaxies appear as faint smudges of light, small and ancient. Some are no more than the first whispers of structure, forming shortly after the Big Bang. They remind us that even in the earliest moments, the seeds of beauty were already planted. Gravity took what was scattered and gave it form, weaving the first patterns of the great dance that continues to this day. The universe's earliest movements set the tone for everything that followed. There is a tenderness in how galaxies move, a patience that transcends time. Their interactions are slow, deliberate, almost meditative. Watching them is like watching eternity exhale, vast, unhurried, serene. And though we can only capture glimpses of their motion through our brief lives, those glimpses are enough to remind us of our place within the infinite. We, too, are part of the same rhythm, born from the same cosmic music that guides their steps. Galaxies also remind us of impermanence. The forms we admire, spirals, clusters, arms, are temporary, fleeting structures in an ever-changing cosmos. Over eons, gravity will alter them, expansion will separate them, and entropy will fade them. Yet that does not diminish their beauty. On the contrary, it enhances it, for it shows that beauty need not be eternal to be real. The galaxies dance precisely because time moves forward, not in spite of it. In their vast silence, galaxies speak of connection. Though separated by incomprehensible distances, they influence one another through gravity's invisible threads. That same force binds stars into systems, planets into orbits, and molecules into living beings. The dance of galaxies is thus the same dance we participate in, on a smaller scale, the dance of attraction, motion, and transformation. Everything that exists moves to the same underlying rhythm. When we look up at the night sky, we see only a fraction of the universe's dancers. Yet each point of light is part of a larger motion, part of an interwoven whole. To know this is to feel a quiet awe, not of distance but of unity. We are not separate from the galaxies, we are their continuation, their children made of stardust and gravity's memory. The cosmos does not end at the edge of the sky, it continues within us, in every thought, every breath, every heartbeat. And so the dance goes on. Galaxies turn, stars burn, planets form and fall apart, and life awakens to witness it all. The universe expands, evolves, changes, yet the pattern remains, motion giving rise to form, form returning to motion. It is the quietest and most beautiful of dances, endless, serene, and true. To watch it is to feel the pulse of creation itself, slow and eternal, a rhythm that connects every galaxy, every atom, and every soul beneath the stars. In the beginning, there was confusion, a darkness not just of space but of knowing. Humanity looked into the night sky and saw mystery painted in pinpricks of light. For thousands of years, we could only wonder, crafting myths to fill the silence, believing that gods and spirits moved among the stars. Yet slowly, through patience and curiosity, that darkness began to fade. Understanding did not come as lightning but as dawn, slow, soft, revealing more with each moment, until the universe began to show its true form. The journey from mystery to knowledge was not simple. It required generations to abandon superstition for observation, to replace story with measurement. Every new discovery seemed to push the unknown further back, like the tide receding from the shore. But each time we thought the ocean of mystery had ended, another horizon appeared. Darkness has a strange habit of remaining just ahead of us, yet it always retreats a little further when met with the quiet persistence of thought. At first, our understanding of the cosmos was bounded by what we could see. The stars seemed fixed, their light eternal, their distance unimaginable. But when we learned that light has a finite speed, a new realization dawned. To look into the night sky was to look into the past. Every glimmer carried a story billions of years old. Darkness, once seen as emptiness, became a window into time itself. The universe was not a void, it was history glowing faintly at the edges of perception. The discovery of galaxies deepened this revelation. Suddenly, the Milky Way was no longer the entirety of existence but one island among countless others. What we thought was the universe became a single swirl of dust in an endless sea of light. It was a humbling moment, one that dissolved human pride but expanded human wonder. Understanding was no longer about control but about belonging, realizing that we were part of something vast, ancient, and beautifully interconnected. Even so, every advance revealed new shadows. For every question answered, another appeared. When we learned how stars shine, we began to ask how they are born. When we mapped galaxies, we wondered what lies between them. The more precisely we measured light, the more we discovered about what we could not see: invisible forces like dark matter and dark energy, shaping everything from the motion of galaxies to the fate of time itself. Understanding brought clarity, but it also revealed deeper veils. Yet that, perhaps, is the nature of all enlightenment. True understanding is not the elimination of mystery but its transformation. The darkness does not disappear, it becomes structured, meaningful, a backdrop against which light can exist. We do not destroy the unknown, we learn how to live with it, how to find its rhythm and purpose. The cosmos, in that sense, teaches us the same lesson life does, that meaning is not found in answers alone, but in the spaces between them. In the 20th century, as telescopes grew powerful and equations precise, the darkness began to whisper new secrets. Radiation, once invisible, revealed the afterglow of creation itself, the cosmic microwave background, a faint echo of the Big Bang. It was as if the universe had left behind a memory of its birth, an ancient sigh frozen into light. For the first time, humanity could trace its origins not through myth but through measurement. The darkness was no longer frightening, it was intimate, familiar, almost tender. But the more we understood, the more we realized how much remained hidden. 95% of the universe is composed of things we cannot see or touch. Dark matter gives galaxies their form, dark energy drives them apart. Together, they shape the grand design of reality, yet both remain invisible. We see their effects but not their essence. It is a strange kind of understanding, one built on absence, where what we know is defined by what we cannot observe. Still, in that absence lies beauty. The fact that the universe can be largely unseen yet completely comprehensible speaks to the elegance of its design. Mathematics becomes our lantern, theory our compass. With each refinement of knowledge, we illuminate new pathways through the dark, not banishing it, but giving it contour. The unknown becomes less an enemy and more a companion, a reminder that wonder is endless and that curiosity is our most faithful form of light. There is comfort in knowing that darkness is not ignorance but invitation. It beckons us to explore, to question, to imagine. The spaces between stars, the silence between signals, these are not voids but potentials. The universe keeps its secrets not to mock us, but to teach us humility. In every unanswered question lies the possibility of discovery, and in every shadow, a doorway to deeper truth. Understanding is not the end of mystery, but the art of walking beside it without fear. Astronomy, perhaps more than any science, is built on patience. To understand the universe, we must accept that time itself is a collaborator. Light travels slowly across cosmic distances, the truths we seek often arrive millions of years late. Yet this delay gives our understanding depth. It means that every observation connects us to something ancient, allowing us to see how the cosmos once was. In that way, darkness is not absence, it is the space where time becomes visible. Through centuries of searching, we have learned that the cosmos is both infinite and intimate. The same elements that burn in distant stars reside within our bodies. The iron in our blood, the calcium in our bones, the oxygen we breathe, all were forged in ancient stellar cores. We are not separate from the darkness that surrounds us, we are its children, its continuation. Understanding this does not make the universe smaller, it makes it home. Even black holes, once symbols of terror, have become sources of insight. They are regions where light cannot escape, yet their behavior reveals truths about gravity, time, and energy. By studying what vanishes, we have learned how space itself bends and flows. Darkness, in this sense, does not conceal but communicates. Every shadow has a message, every silence has a shape. The universe, when we learn to listen properly, speaks most clearly in its quietest places. Quantum physics deepened this lesson further. It showed us that reality is not fixed but fluid, that observation shapes existence, and uncertainty is not a flaw but a fundamental feature of nature. The cosmos is not built on rigid laws alone, but on possibilities and probabilities. Darkness, then, becomes a space of potential, the realm from which all new realities emerge. Understanding it means embracing ambiguity, learning to see truth not as certainty, but as unfolding. In the cosmic sense, our knowledge is still in its infancy. We stand on the edge of an immense ocean of uncharted understanding, our lanterns bright but small. Yet every generation pushes the shoreline further, turning once terrifying darkness into familiar territory. This progress is not just intellectual, it is emotional. Each discovery teaches us to feel at home in the unknown, to find peace in the immensity that once overwhelmed us. The night sky, once filled with gods, now fills us with gratitude. It is worth remembering that darkness is also protection. Without it, stars could not shine. Contrast gives light its meaning. The vast expanses between galaxies allow them to exist without tearing each other apart. The cold emptiness of space preserves the delicate balance of the cosmos. What seems like nothingness is, in truth, structure, a silence necessary for the song to be heard. Understanding the universe requires loving its darkness as much as its light. Even in human thought, this principle echoes. Our minds mirror the cosmos, light and shadow intertwined. We understand not through perfect clarity, but through contrast, through the gradual unveiling of what was hidden. Every act of insight arises from confusion first. The darkness within us is not ignorance but the fertile ground of creativity. Just as stars are born from collapsing clouds of dust, understanding emerges from the gathering weight of unknowing. When we gaze at the stars now, we no longer see mystery alone, we see history, structure, and connection. Yet the awe remains. Knowledge has not dimmed wonder, it has deepened it. To understand why galaxies spin or why gravity bends light is not to make them less miraculous. It is to see the pattern beneath the beauty, to realize that the laws of physics themselves are poetry written in motion. The more we learn, the more the cosmos feels alive. Technology has become our new set of eyes in the dark. Telescopes that see in infrared, X-ray, and radio wavelengths reveal what the human eye cannot. Through them, we witness stars being born, galaxies colliding, and planets forming from dust. We have learned that even the emptiest regions of space hum with energy. Understanding, in this era, is not about reaching an end but expanding perception, opening new senses to reality's infinite frequencies. And yet, despite all we have learned, the great mysteries endure. What is dark energy? What lies beyond the observable horizon? How did existence itself begin? These are questions that remind us that the darkness will never fully fade, that understanding is always partial. But that incompleteness is not failure, it is beauty. The unknown is what keeps the universe alive, what keeps us searching, imagining, and reaching further. Without mystery, there would be no motion. Philosophically, this has changed how we see ourselves. We are no longer the center of the cosmos but participants in its unfolding story. The darkness that once frightened us has become the medium through which we discover meaning. We realize that to understand the universe is also to understand ourselves, our fragility, our curiosity, our longing for connection. Every photon that reaches our eyes carries not just information, but kinship. The boundary between ignorance and insight is not a wall but a horizon. We move toward it endlessly, and it moves with us, always just beyond reach. That is not futility, it is grace. The darkness fades only to reveal new forms of it, softer, more intricate. In each revelation lies the seed of another question, another journey. The pursuit of understanding is itself the purpose, not a destination, but a way of being within the universe. Even time, once an abstract measure, becomes a bridge between darkness and understanding. It links the light of ancient stars to our present moment, connecting the infinite to the immediate. When we study the cosmos, we are, in essence, studying memory, the universe remembering itself. Every photon, every equation, is a fragment of that remembrance. Understanding is not discovery alone, it is recognition, the cosmos seeing itself through human eyes. There will always be limits to what we can know. Our instruments, our minds, even our lifespan, impose boundaries. But those boundaries define the shape of our curiosity. Just as the edge of a shadow sharpens the light beside it, our limitations make discovery meaningful. To live in a universe that can never be fully known is to live in perpetual dialogue with mystery, a conversation without end, where silence and sound alternate in perfect rhythm. The deeper our understanding grows, the more it humbles us. We see that every triumph of reason is small compared to the immensity it seeks to grasp. Yet humility itself becomes enlightenment. To stand beneath the night sky and know both how much and how little we understand is to feel the truth of existence. We are fragments of awareness in a vast ocean of being, but we are aware, and that, in itself, is light enough to navigate eternity. In the darkness between galaxies, where no starlight reaches, quantum fields still shimmer faintly, particles emerge and vanish in silence. Even the emptiest void is alive with possibility. The cosmos has no true darkness, only degrees of hidden illumination. Understanding this changes everything. It means that even in the deepest night, something is happening, creation continues, quietly, invisibly, endlessly. There is an old truth that the universe hides its secrets not out of cruelty, but because the act of uncovering them gives them meaning. Knowledge gained too easily would be hollow. Discovery is sacred because it requires patience, humility, and wonder. The cosmos gives us mystery as a gift, a way to grow alongside it. Every light we find is earned, every shadow we unveil a lesson in perseverance. When we look to the farthest galaxies, we are also looking inward into the mind that dares to comprehend infinity. Darkness fades not because it is conquered, but because perception evolves. The universe has always been illuminated, we are only now learning how to see. Each new understanding is like opening another eye, awakening a deeper awareness that has always been waiting within us. Perhaps, in the end, understanding is not about light replacing darkness at all, but about realizing that they were never opposites. Light needs darkness to be seen, knowledge needs mystery to have purpose. The universe breathes between these two, illumination and shadow, discovery and wonder. And we, fragile observers adrift in a sea of stars, are the witnesses to that breath, the part of the cosmos that can finally say, softly and knowingly, that darkness was never emptiness, but the beginning of seeing. The universe has always spoken in patterns, not words. From the earliest light to the deepest void, it carries the traces of its own explanation. Every particle, every fluctuation, every gentle drift of galaxies reveals something of how it came to be. It does not need to be translated, it simply is. The universe explains itself through its own structure, through laws that emerge not from outside intervention but from internal harmony. Each motion, each silence, is a sentence written in physics. As scientists observed deeper into space, they found that the universe contains not randomness but coherence. The same ratios that govern atoms seem to guide stars, the same geometry that shapes galaxies appears in the structure of cosmic filaments. From quantum fields to galaxy clusters, the principles repeat themselves in different languages of scale. This recursion of order suggests a self-explaining system, one that arises from consistency rather than coincidence. It began with the realization that everything observable stems from a few simple laws. The expansion of space, the formation of elements, the behavior of light all can be traced to mathematical relationships that remain unbroken. The beauty lies not only in their accuracy but in their self-sufficiency. The universe requires no external push to maintain these patterns. It evolves because its equations naturally produce evolution, because change is encoded into its very geometry. Einstein once remarked that the most incomprehensible thing about the universe is that it is comprehensible. This paradox hints at a deeper truth, that the laws of physics are not separate from the universe, they are the universe. The cosmos does not follow the rules, it is the rules in motion. The connection between thought and existence emerges from this unity. By observing, we uncover reflections of the same structure that made us capable of understanding at all. When cosmologists study cosmic background radiation, they see more than a faint afterglow. They see a pattern of fluctuations that tells the story of creation itself. These ripples contain information about density, temperature, and the seeds of galaxies. The data fits perfectly within the predictions of general relativity and quantum field theory. In this light, the universe becomes its own textbook, each photon a preserved page from its opening chapter. Over time, we have learned that the laws of nature are remarkably stable. Gravity behaves the same everywhere. The constants of light, mass, and charge never deviate, no matter the distance or epoch. This consistency means that the universe explains its past and future simultaneously. It is as if it has built-in memory and foresight, its principles linking the birth of atoms to the deaths of stars without alteration. The same logic binds every moment together. One might think that such precision implies external design, but the truth may be simpler. The universe could exist this way because only such balanced laws permit persistence. Random systems collapse, structured systems endure. Over cosmic timescales, only self-consistent frameworks survive. Thus, the universe's ability to explain itself may be a natural result of stability, a byproduct of the fact that coherence is what lasts long enough to be observed. The universe's story is not told through symbols alone but through experience. Each experiment confirms a pattern already written into existence. When a particle collides or a galaxy spins, it behaves according to principles we have extracted from centuries of observation. What we call discovery may merely be recognition, the gradual unveiling of rules that were always present, waiting to be understood by beings made from the same elements that obey them. In this self-explanatory cosmos, even randomness has a role. Quantum uncertainty, rather than introducing chaos, adds depth to the story. It allows for diversity, for structure to form from fluctuations. Without it, no galaxies would coalesce, no stars would ignite, and no observers would exist to question the process. The universe teaches balance through contrast, order emerging from chance, and predictability arising from unpredictability. Time, too, fits within this self-contained explanation. It flows forward not because something external wins it, but because entropy, the natural drift toward disorder, gives direction to change. Each second stretches from the expansion of the universe, from the cooling of radiation and the motion of matter. The arrow of time arises from within, not from beyond. The universe defines its own past and future by how it evolves internally. In understanding how the universe expands, forms, and cools, scientists realized that it not only obeys laws, it encodes them in the very fabric of existence. Space-time curves because energy tells it to, matter clumps because gravity whispers through geometry. These are not imposed behaviors, they are consequences of what space-time and energy are. Thus, the universe's logic is self-contained, like a melody that sustains itself through resonance. The more we map the cosmos, the more we find echoes of its origins in every part. Galaxies carry the fingerprints of ancient fluctuations. Stars preserve the chemistry of the Big Bang. Even empty space hums faintly with the energy of creation. It is as though the universe keeps explaining itself through repetition, offering the same answer in countless variations. Every observation leads not to confusion, but to deeper affirmation of coherence. The self-explaining nature of the cosmos also extends to its future. As dark energy continues to shape expansion, it follows the same rules that governed the earliest moments. The balance between gravity and acceleration remains consistent, only the dominant force changes with time. The universe's long-term trajectory is encoded within its initial conditions and unchanging laws. It evolves according to what it has always been, a system that defines its own direction. This realization brings humility. We once thought ourselves separate observers, deciphering an external puzzle. Now we see that we are participants within the very process we study. Our minds, built from stardust and bound by physics, reflect the same logic that governs galaxies. To understand the universe is, in a sense, to understand ourselves. Our curiosity is one of its ways of knowing, our questions a continuation of its self-description. Some thinkers propose that the universe may be a kind of computational system, each event a step in a grand calculation. If so, its equations are both hardware and software, processing reality without error or pause. The constants are fixed, the code unbroken. Such a model aligns with the self-explaining idea. No external programmer is required once the initial rules are in place. The program runs because running is its natural state. Yet even in its predictability, the universe allows room for wonder. The emergence of life, consciousness, and art adds new layers of self-reference. We are fragments of the cosmos capable of reflecting upon the whole, closing the loop of explanation. Through observation, the universe becomes aware of its own patterns. Through science and imagination, it articulates what it has been expressing since the beginning, an unbroken conversation with itself. In the background of every discovery lies the hum of cosmic microwave radiation, the oldest message in existence. It tells us the temperature, age, and curvature of the universe. From that faint glow, we reconstructed the entire timeline of cosmic evolution. No other system carries such complete internal evidence of its own past. The universe has preserved its memory in light, encoded so that any intelligence, anywhere, can read it. This self-documentation gives the universe continuity. Stars may die, galaxies may fade, but the principles endure. Even when everything cools to blackness, the structure of space-time will remain, holding the imprint of all that came before. In that sense, the universe will never stop explaining itself, it will simply shift to quieter forms of communication, from radiation to gravity, from motion to stillness. There are still mysteries: dark matter, dark energy, and quantum gravity. Yet even these gaps exist within a framework that allows for their discovery. The universe hides nothing that cannot, in principle, be known. It gives clues through its own consistency, through subtle gravitational lensing, through cosmic background distortions, through the rhythm of pulsars and the brightness of supernovae. The clues are there because the universe is transparent to those who listen carefully. Some physicists now speak of a self-organizing cosmos, where order arises spontaneously from simplicity. In this view, complexity is not an anomaly but an inevitability. The laws of physics are few, but their interactions create boundless diversity. Galaxies, ecosystems, and civilizations all emerge from the same principles, scaled and adapted. The universe's self-explanation is recursive, it builds complexity that can, in turn, perceive the simplicity beneath it. When we simulate cosmic evolution in computers, the results often mirror reality. The same equations, when allowed to run, produce filaments of galaxies and voids identical to those seen through telescopes. This correspondence is not coincidence, it is verification that the universe's logic is internally consistent. The simulation succeeds because the universe itself is predictable within its rules, a self-contained system that behaves as expected from its own design. The deeper scientists look, the fewer exceptions they find. The constants that define the speed of light, the strength of gravity, and the charge of the electron remain immutable. Every measurement reinforces the same truth: reality is coherent. The universe does not contradict itself. That coherence, more than any single discovery, is the grandest explanation of all. It tells us that what exists does so for consistent, understandable reasons. Even beauty has a place in this self-explaining structure. The symmetry of equations, the elegance of orbital paths, and the harmony of spectra all suggest that the universe values balance. This aesthetic dimension is not human projection but a property of mathematical truth. Harmony and coherence are indicators of stability. The universe appears beautiful because beauty, in the language of physics, is a synonym for consistency. As we advance technologically, we peel back layers of scale, from the subatomic to the cosmic horizon, and find the same logic repeating. It is as though the universe has written itself fractally, each level containing echoes of the whole. The symmetry of particles mirrors the symmetry of galaxies, the fluctuations of quantum fields mirror those of early cosmic plasma. The repetition reinforces the idea that the universe's explanation lies within itself, not beyond. Eventually, as stars burn out and galaxies drift apart, the universe will fall into quiet expansion. Yet even then, its logic will persist. The constants will remain constant, the geometry unbroken. There will be no new message to uncover, only the silent continuation of the same truth, that existence, once begun, unfolds according to its own timeless equations. In its silence, the universe continues to affirm what it has always said: I am self-contained. We, too, are part of this ongoing explanation. Every discovery we make is the universe discovering something about itself. Every formula we write is a reflection of its inner order. The story of science is not separate from the story of creation, it is its continuation, written through us. The universe's self-explanation is recursive, and we are one of the recursive layers within it, translating structure into understanding. In the quiet moments between discoveries, when telescopes rest and laboratories dim, the universe still hums with meaning. It does not need to be observed to exist, yet its existence invites observation. The stars, the dust, the light, and the void all whisper the same truth in different tones. To listen is to understand. To understand is to participate. The universe explains itself endlessly, patiently, through the music of its own design. And perhaps that is the greatest revelation of all, that no divine translation, no external script, is required. The cosmos contains the rules of its own becoming, the language of its own persistence. From the quantum foam to the farthest galaxy, it has written a continuous, self-referential poem of existence. The universe, in explaining itself, has already explained us too, for we are its words, its patterns, and its enduring echo. There is a quiet moment that comes after discovery, a pause in the laboratory, a stillness between telescope readings when the scientist looks not at the data, but through it. Beyond the numbers lies a sense of wonder that cannot be measured. It is not triumph, not pride, but something more tender, awe. The kind that makes one exhale softly, realizing that what they've uncovered was always there, patiently, waiting to be found. It is a humility that science alone can teach, one that whispers, the universe does not need you to notice it, yet it allows you to understand it. When Edwin Hubble first recognized that galaxies were receding, he did not shout his findings to the world. He noted them, checked again, and again, until certainty replaced surprise. The realization that the universe itself was expanding filled him not with noise, but with silence. Astronomers, more than most, live within the tension between immensity and meaning. They spend lifetimes gazing into distances that make human concerns seem small. And yet, in that smallness, they find the beauty of belonging to something unimaginably vast. For a scientist, awe is not the enemy of logic, it is its reward. The more they learn, the deeper the sense of wonder grows. Every equation solved opens a deeper mystery beneath. The laws of physics may explain motion, gravity, or light, but they also hint at the elegance of a system so complete that it creates observers capable of marveling at it. It is not faith in the supernatural that drives them, but reverence for natural law itself and admiration for a cosmos so precise it borders on the sacred. When scientists gather at conferences or peer through long exposures at ancient light, the atmosphere is often quiet, almost reverent. They speak softly, as if not to disturb the galaxies flickering across their screens. Each discovery carries with it a paradoxical calm, because finding a truth does not reduce the mystery, it deepens it. For every question answered, 10 new ones unfold. The awe is not in completion, but in the endlessness of understanding. In the dark rooms of observatories, where computers hum softly and red lights glow faintly against the metal of instruments, there is a ritual of patience. Hours of silence pass as data accumulates, pixel by pixel. Then, an image forms, a distant cluster, a faint trace of a supernova's afterglow, and in that fragile outline, someone's entire career finds meaning. The scientist's awe is not loud or explosive, it is the gentle intake of breath when the universe briefly shows one more of its secrets. Even theoretical physicists, working far from telescopes, feel this same quiet reverence. Their awe lives in equations, in the symmetry of a formula that unexpectedly unites two distant ideas. When Einstein derived general relativity, he described the experience as sensing the harmony of the spheres, an almost musical recognition of nature's coherence. To such minds, mathematics becomes a form of worship, a bridge between human thought and cosmic order. Awe in science is rarely dramatic. It often appears as stillness, the quiet glance exchanged between researchers when an anomaly turns out to be real, or when a pattern in data perfectly matches prediction. That brief silence holds centuries of effort, generations of thought. It is the moment when humanity, for an instant, feels synchronized with the universe's own rhythm, and every sleepless night spent seeking understanding feels worthwhile. When the first image of a black hole was revealed, surrounded by its glowing ring of accretion, the room where scientists watched it unfold fell utterly still. Years of algorithms, failed attempts, and endless calculations came together into that one haunting image, a void framed in light. No one spoke at first. Then, softly, someone whispered that it looked exactly as the equations predicted. The awe was not in the surprise but in the confirmation, Nature had once again obeyed the rules it wrote for itself. For cosmologists, awe often comes from scale. To hold in one's mind both the quantum trembling of particles and the cosmic stretch of galaxies requires a certain tenderness of thought. The human mind, built to track seasons and stories, reaches beyond its limits to imagine billions of years and incomprehensible distances. To think about the universe honestly is to surrender to humility. Awe grows naturally from that surrender, because understanding does not diminish beauty, it reveals it. The scientists who study cosmic microwave background radiation speak of it as a conversation with time. Those faint microwaves are the universe's first words, frozen across space since moments after creation. Measuring their fluctuations is like reading the wrinkles of time's earliest fabric. Every graph and contour represents a whisper from the past, a message that says, "I was hot, I was dense, I was expanding." The awe lies in realizing that, across the void, we can still hear it speak. When spacecraft like Voyager sent back their final photographs, looking outward toward the infinite dark, scientists described the feeling as both pride and sadness. The pale blue dot of Earth, captured from billions of miles away, became a symbol of fragility. Carl Sagan's words still echo through laboratories and classrooms, "That's us." Every discovery beyond our world deepens that awareness that we are small, but not insignificant. The awe lies not in our size, but in our capacity to comprehend our smallness. Awe in science has no hierarchy. It lives equally in the heart of a child holding a magnet for the first time and in the mind of a physicist watching gravitational waves ripple across detectors. Both moments are linked by the same spark, recognition. The sense that we are glimpsing something eternal, something that existed long before us and will remain long after. That spark connects curiosity to reverence, and both to understanding. At times, scientists describe their work as listening to nature. The phrase is not poetic exaggeration, it is literal. Whether through radio telescopes tuned to cosmic signals or particle detectors buried deep underground, they are attuning themselves to the faint murmurs of the universe. Each detection, each flicker of evidence, feels like the cosmos acknowledging their patience. The awe lies in that dialogue, however quiet, between the infinite and the finite. There is a particular kind of awe reserved for when theory and observation meet perfectly. When numbers predicted decades before are finally confirmed by experiment, it feels like the universe nodding in agreement. The discovery of the Higgs boson carried that feeling. The particle had existed only in equations, a mathematical ghost, until colliders revealed it in a flurry of data. The applause that followed was full of joy, but beneath it, there was reverence for nature's unwavering consistency. For all their rationality, scientists often describe beauty as a measure of truth. An elegant equation feels more trustworthy, as though nature prefers simplicity to complication. This aesthetic sense is not vanity, it is intuition honed by centuries of discovery. The universe, it seems, favors symmetry, proportion, and grace. Awe, then, is not just emotional, it is intellectual recognition of beauty aligned with truth. The night sky itself remains the original source of awe. Long before equations or instruments, early humans looked upward and felt the same pull that modern scientists still do. The stars have not changed, only our ability to interpret them has. Every generation of astronomers inherits that same ancient wonder, now guided by precision tools but rooted in the same emotion, a longing to know why it all exists and how we fit within it. In the modern era, scientists carry that awe across disciplines. Biologists marvel at the self-organizing beauty of cells. Chemists at the perfection of atomic bonds, physicists at the unity between light and gravity. Each field, no matter how technical, encounters moments of quiet astonishment when nature reveals its hidden order. These are not just professional successes, they are emotional awakenings, reminders that knowledge and wonder are not opposites but partners. The awe deepens when discovery challenges old beliefs. When the expansion of the universe was first understood, it dismantled centuries of assumptions about permanence. The cosmos was not eternal but dynamic, evolving, alive. That realization carried both excitement and humility. To learn that even the stars are transient is to face the truth that nothing endures unchanged. Yet in that impermanence lies a strange comfort, the beauty of participation in something vast and ongoing. Scientists often speak of feeling small when confronted with cosmic scale, but that smallness is not despair. It is liberation. To realize that our planet is a tiny fragment of a larger whole gives perspective, dissolving arrogance and fear alike. In that humility, awe flourishes. It becomes not just admiration of the universe but acceptance of one's place within it, a single conscious moment in the long unfolding of cosmic time. When gravitational waves were first detected, confirming Einstein's century-old prediction, researchers described the moment as hearing the universe's music. The merger of black holes had produced a ripple through space-time itself, a soundless vibration that humanity could finally record. The awe of that moment transcended measurement. It was the first time we had listened to the fabric of reality sing. Such discoveries remind scientists that even the most abstract theories eventually touch something profoundly real. Awe also carries responsibility. To understand the universe is to become its caretaker, in thought if not in action. Scientists know that knowledge grants power, and power requires humility. The gentle awe they feel is not just admiration, it is reverence tempered with restraint. The cosmos invites exploration, but it also demands respect. The deeper they look, the more aware they become of how little can truly be controlled. There is a shared understanding among scientists that their work is temporary, but the pursuit is eternal. Each discovery builds upon countless forgotten ones, each observation a bridge for future eyes. Awe binds generations of thinkers across time, linking Galileo's telescope to Hubble's deep field and beyond. In that continuity lies comfort, the sense that curiosity is the most enduring legacy humanity will ever leave behind. The gentle awe of science is also a refuge. In a world often noisy with opinion and distraction, the cosmos remains silent and honest. It does not flatter, it does not deceive, it simply exists, patiently waiting for comprehension. Many scientists find peace in that neutrality, a kind of sanctuary in the impartial beauty of natural law. The universe, indifferent to praise, rewards patience with understanding. Sometimes, awe arises from failure. Experiments that do not behave as expected often lead to breakthroughs. In those moments, scientists learn to listen differently, to consider that nature is not wrong, only misunderstood. Each failed hypothesis becomes a step closer to truth. The awe here is quiet but profound, the recognition that the universe is always right, even when it surprises us. For those who dedicate their lives to exploration, awe becomes a companion. It follows them through sleepless nights, long data sessions, and moments of uncertainty. It is the steady reminder of why they began, to learn not just for progress, but for connection. Science, at its heart, is an act of communion with the universe, and awe is the language spoken between them. When astronauts look back at Earth from orbit, they often describe a feeling scientists know well, the overview effect. Seeing the planet whole, fragile, and glowing in the darkness transforms perception. Borders vanish, divisions blur. The awe of that sight cannot be quantified, but it resonates deeply. It is the same awe found in equations, in star fields, in every moment the universe allows us to see ourselves within it. Even in moments of solitude, scientists feel accompanied by the past, the quiet presence of those who came before, who asked the same questions under different skies. Their awe is cumulative, layered through generations, deepened by every discovery and every unanswered mystery. It is a lineage of wonder, stretching back through time as far as curiosity itself. To witness the universe explaining itself is to witness beauty beyond art. The equations, the data, the stars, they form a narrative so intricate it defies imagination. Yet we are part of that story, capable of reading it, capable of awe. In the end, science does not extinguish mystery, it refines it into understanding. The awe remains, gentle and enduring, humming beneath every discovery like the background radiation of wonder itself. And so, the scientists continue, quietly, patiently, reverently. They map galaxies, split atoms, and trace light across eons. Not for glory, not for conquest, but for that one still moment when data becomes revelation, when understanding dawns softly like light over a horizon of mind. In that moment, they feel it again, the gentle awe that began it all, the whisper of the universe saying, "You were meant to see me." The universe stretches outward, not with noise or violence, but with an almost meditative calm. Every second, galaxies drift farther apart, carried on invisible waves of expansion that have persisted since the dawn of time. To look into the night sky is to see not chaos, but an organized drifting, a quiet, continuous unfolding that has no clear edge, no certain end. Astronomers once thought the cosmos might collapse back in on itself, but instead, it continues to breathe outward, softly and endlessly. When we gaze across the stars, we are seeing billions of years compressed into a moment of light. That starlight travels across unimaginable distances, slipping through the dark ocean of space, untouched by time or matter. Some of it began its journey before Earth even formed. The horizon of our knowledge stretches with it, expanding as telescopes grow stronger and theories grow wiser. But beyond even the farthest detectable galaxies lies a curtain of unreachability, the cosmic horizon, where light itself cannot reach us in time. That horizon is not the end of the universe, but the limit of our seeing. Beyond it, reality continues unseen, unmeasured, but not unmade. It is a gentle reminder that the cosmos is far greater than what our instruments reveal. Each improvement in observation merely deepens the mystery, not resolves it. The universe, in its quiet expansion, reminds us that discovery is infinite, a river without a shore. The scientists who watch this distant stretching often speak softly when they describe it. There's reverence in their tone, not unlike monks describing an ancient prayer. They know that each number, each image captured by a telescope, is a sacred text of nature written not in words, but in wavelengths. The horizon is a kind of scripture, a cosmic psalm written in starlight and distance. It's easy to forget that our galaxy, too, is part of this expansion. The Milky Way drifts, along with all others, like a leaf caught in an endless cosmic breeze. From our view on Earth, it feels still, constant, but on the scale of the cosmos, we are soaring. Every heartbeat carries us farther from where we once were, deeper into a future we cannot yet see. Dark energy, that invisible force behind the expansion, remains one of the universe's quietest enigmas. It is everywhere and nowhere, pushing galaxies apart with gentle persistence. Some physicists imagine it as a property of space itself, a whisper of pressure filling every void. Others wonder if it's a sign that our understanding of gravity is incomplete. Whatever it is, it has shaped the story of existence more than any other known thing. When we imagine the end of everything, we often picture silence and stillness, but the truth might be softer. The cosmos may continue expanding forever, galaxies drifting apart until even light cannot bridge the space between them. Stars will fade, matter will thin, and yet space itself will keep breathing outward. It is not an ending of violence, but of distance, a separation so vast that time loses meaning. In that far, future emptiness, the last sparks of energy will still move, quietly, through the darkness. Perhaps new laws will emerge, new ways of being that we cannot now conceive. The universe may reinvent itself, as it has done before. Or it may simply continue, endlessly unfolding, serene and eternal. Every generation of astronomers inherits the same wonder. The tools change, from glass lenses to space telescopes, from inked notebooks to quantum simulations, but the all remains untouched. To study the universe is to stand in front of a vast ocean and realize you will never reach its other side, yet still love its horizon. And so, we continue to look outward. Each observation, each discovery, brings us a little closer to understanding, even if the goal forever moves away. The horizon is not a barrier, but an invitation to keep asking, to keep dreaming. In a way, it is the universe's most beautiful kindness, to give us something that will never be finished. Galaxies continue their quiet dance, drawn together by gravity and pulled apart by expansion. Some collide and merge, creating bursts of new stars, others drift alone into the cosmic dark. And through all of it, the laws of nature remain consistent, elegant, and calm. There is beauty in their endurance, in the way reality holds itself together, even as it grows apart. As we learn more, we also learn to be humble. The universe is not built for our understanding, and yet, it allows us glimpses. A particle here, a pattern there, small clues to a vast design. Every time we solve one puzzle, we find 10 more waiting quietly behind it. This endlessness is not frustrating, it is freeing. It means the story will always go on. From the silent cold of the cosmic microwave background to the flickering edges of quasars, every part of existence hums with continuity. The universe is not static, it is a song still being played, each verse stretching into eternity. We may never hear the final note, but we can feel its rhythm beneath everything. Even time itself is elastic in the presence of this vastness. What seems like billions of years to us may be a moment in the universe's own perception. The past, the present, and the future are not separate things but threads in a single, woven light. The horizon holds all of them, layered together like the pages of a book still being written. The future of cosmology lies not in answers, but in deeper questions. What came before the Big Bang? Why does dark energy exist? Are there other universes breathing beside ours, separated by thin veils of space and law? Each question opens another door, leading us farther into a labyrinth of beauty. Humanity's curiosity is, in a way, part of the universe's own awakening. Through our minds, the cosmos becomes aware of itself, tiny sparks of understanding flickering in one of its corners. We are both observers and participants, woven from the same particles that drift in distant stars. The horizon we look toward is, in truth, a mirror. There is peace in knowing that the universe will outlast us, yet still hold our trace. Every signal we send, every image we capture, becomes part of its fabric. Our radio waves will travel outward forever, faint whispers crossing the dark, becoming echoes in the eternal night. Someday, all human structures will fade, but our curiosity, that longing to look beyond, will remain in the cosmic story. The stars we studied will have burned out, but the questions we asked will still ripple through the void. The act of wondering is itself a kind of creation. And perhaps that is the secret meaning of the endless horizon. It is not meant to be reached. It exists so we may walk toward it, again and again, in quiet awe. Every step forward is a new discovery, every glance upward, a prayer. So the universe expands, and so do we. Each moment carries us farther from our beginning, yet closer to understanding the boundless whole. The horizon may forever move away, but the journey, that beautiful, unending pursuit, is what makes us alive. To watch the night sky is to hear a lullaby older than life, written in silence and motion. Every star, every shadow, every whisper of dark energy is part of the same song, the song of existence unfolding. And as that song continues, softly, endlessly, we find comfort not in knowing how it ends, but in being part of its beginning, forever moving forward, forever looking up, toward the endless horizon ahead.